Hello guys, I'm back once again. So our next talk is about Python. Obviously Python. Python is full of abstractions that can help us write clean code by diving into one of Python's most magical abstractions, the insertion of self into methods. Our next speaker wants to show that we can understand those abstractions and that we can write abstractions of our own that allow us to write better software. That's right. Up next, we have another wonderful talk on the magic of self and how Python inserts self into methods.
Thank you all for joining this stream. I was planning on wearing my pajamas today, but it's really cold in here, so I decided to put on this crazy sweater instead. Still, I really like the idea of having a lazy conference from the comfort of my own home. Anyway, today I'll be talking about self in Python, and in doing so, I will introduce something called the descriptor protocol. But first, I'm going to briefly introduce myself. I am Sebastiaan, and I live in the Netherlands. During the day, I work as a Python developer and codesmith for the Ordina Pythoneers. I'm also one of the 3 owners of Python Discord, an online Python community. Together with about 100 volunteers, we try to provide a safe and welcoming environment for Python enthusiasts. But we also do things like organizing Python-related events or helping out other organizations in the Python ecosystem. Finally, I'm also a volunteer for EuroPython, another very amazing Python conference. If you haven't already, you should definitely check it out in 2022. Alright, that's enough about myself. So let's dive into the magic of self in Python. I'd like to start with something that Guido van Rossum said on Twitter a while ago. In a conversation about Python's many magical features, Guido said that, from day one, there was deep magic hiding in some places, designed to quietly help users. And it's true. This is why people say that Python is a very high-level programming language. There's a lot of magic in Python that abstracts away those pesky implementation details so you, the end user of Python, can focus on your business logic. You get a lot of very high-level interfaces to play around with, and you rarely have to worry about the logic underneath that makes it all happen. Some of this magic is of the very arcane kind, the kind that you and I, mere mortals, don't really get to play with, as it's hidden away deep inside of Python's internals. But a lot of that magic is not. It's there for you and me to play around with and to create high-level interfaces of our own. Today, I'm going to dive into one of the most magical things in Python, that when you call a method, you get the value for self for free. Without doing anything, Python has magically inserted the thing you called the method on as the argument for self. By diving into the magic of self, I hope to show you that magic in Python is not something to be afraid of. But you can pick it up and use it to write better software of your own. So, what is the magic of self? To make sure that we're all on the same page, I'm going to implement a very simple class. The class itself is not going to be very exciting or thought-provoking or pretty much do anything interesting at all. It's only meant to illustrate what the magic of self is. As you can see, I have a very simple class called guitar. The only thing it does for now is that if you pass a name to it, the dunder init method will assign the attribute name to whatever name you gave the guitar. This means that if I call my class like this, here I'm using the name of one of my bases, Warwick Streamer, I get a guitar instance and I can assign a name to it. In this case, I'm assigning the name Warwick to it, as I think that's a name that nicely describes what it is. Now that I have a Warwick guitar instance, I can simply get its name by accessing the name attribute. So far, nothing really interesting is going on, so let's add another method to this class. The method that I'm adding is a plain note method that will mock the guitar playing a note, as actually playing a note on a guitar with Python is quite hard. Basically, I can call the method on a specific guitar, pass in the note I want to play as an argument, and Python will print the name of the guitar, place the note, followed by whatever note I passed in. So if I call this method on my Warwick bass, pass in the note C#, the musical note, not the programming language, and hit enter, Python will print out the message my Warwick streamer plays the note C#. Nothing special, right? Well, if we zoom in on the function definition of the plain note method, we can see that something odd is going on. I know that I'm so used to adding it that it's almost subconscious, and in fact my IDE mostly does it for me, but this function actually has two parameters, not just one. It has a parameter I've called self and a parameter I've called note. But if we now look at how I called the method, you can see that I only gave it one argument, and it's clear that that argument, C#, ended up with the parameter note. So where does the argument for self come from? If you call a function, all parameters without default values should get an argument. Is this some kind of special exception? In fact, it's not, but something magical is going on. What has happened is that Python automatically inserted the instance, my Warwick here, as the first positional argument when calling the function. And this is the magic of self. Somehow, without us having to do anything at all, Python will insert the instance you're calling the method on as the first argument. However, while you may think this is some deep arcane magic that Python just performs for you, there's actually a well-defined protocol behind it, the descriptor protocol, that you can use yourself as well. And that's what I'm going to talk about today. But first, I have to explain what happens when you define a function within a class body. What exactly are methods in Python? To understand what methods are, we have to look at what happens when you define a function within the body of a class. As everything in Python is an object, including classes, if you're defining a class, you are creating an object of type. I'm going to represent that class object by this rectangle. And just to be sure, with object I don't mean the potential guitar instances you could create with this class, but the actual class itself, the guitar class. Now let's zoom in on what happens when Python gets to the function definition of the plain note method. Once again, since everything is an object, Python will create another object for you, a function object, an instance of the type function that contains everything there is to know about this function, including the code it has to run when you call the function. Now, since we don't really have a use for objects that are just floating around somewhere in memory, without a name referring to them, a function definition will also bind a name to the function object. Since we are defining this function within the context of a class body, this name will not just be a regular name, but it will be an attribute of the guitar class. In this case, Python will bind the attribute plain note of the guitar class to the function object in memory. However, it is important to note that our method is still mostly just a regular function object. But if our method is just a regular function object, what on earth is going on with self then? One really important observation is that we've assigned a class attribute to the function object. This may look quite innocent. Why would it matter that it's a class attribute instead of a regular name? But this is actually an important aspect of the magic of self. And to see why, we need to look at what happens when we access that function object using an attribute. Since we've assigned a class attribute to the function object, we can access the method as an attribute of the class, guitar.playNote. If I do that, you'll notice that I simply get back the function object. This is just a normal function object. There's been no magical insertion of self yet. That makes sense, since we don't even have an instance to insert as the argument for self yet. We're just accessing it on the class itself. Now let's see what happens when we access the playNote method as an attribute of an instance. First, I'm going to recreate my Warwick instance, and then I'm going to access the playNote method as an attribute of the instance. If you think about that, it's a bit weird. I just made a big point of saying how we've assigned a class attribute to this function, and now I'm trying to access it as an attribute on a guitar instance. So what's going on here? Well, this has to do with the way attribute access works in Python. If you access an attribute on an object, like I'm trying to do now on my Warwick object, Python will first look at that object to see if it has that attribute. If it does not have that attribute, like how my Warwick does not have a play note attribute itself, Python will then move on and look at the class of the object. Does the class of the object have an attribute with that specific name? In this case, it does. But if it does not, Python will then look at all the other classes in the method resolution order, all the parents of the class, to see if they have such an attribute. So accessing an attribute isn't as simple as you might think. There's actually an entire lookup sequence behind it. And in fact, as we'll see now, what I just told you is a simplified version of what actually happens. Because if I now press enter and actually show you what accessing this attribute on the instance gets me, you'll see that I don't get the irregular function object back. Instead, I'm getting something called a bound method. And it's precisely this bound method that already knows what the value for self must be, the object you've used to access this bound method. So what is crucial here is the way in which we access the function. Did we use a class attribute or did we use an instance attribute? And this is because objects, like functions, can modify what happens when you access them via an attribute. They can hook into the attribute lookup process to modify what will happen by implementing something called the descriptor protocol. The descriptor protocol is what really powers the magic of self in Python. It allows objects to customize what happens when you get attributes, set attributes, and delete attributes. One important aspect of descriptors is that they're assigned to class attributes. So it's the object that you're trying to access that implements the protocol, not the class that owns the attribute. The descriptor protocol consists of 3 special or dunder methods. The dunder get method is involved in customizing attribute lookup, like simply accessing warwick.playNote. The dunder set method is involved in customizing attribute assigning, like if you assign something to warwick.playNote. And finally, the dunder delete method gets called when you delete the attribute that is assigned to the descriptor, like del warwick.playNote. Descriptors do not have to implement all the methods in the descriptor protocol. Instead, they can just implement the methods they need to do their work. As you've probably already guessed, functions are such descriptors. They implement the dunder get method to customize what happens when you get a function using an attribute. To get a better idea of how descriptors work, I'm now going to implement a simple descriptor that also customizes attribute lookup. For my example, I'm going to implement a descriptor for my guitar class. To make some room for it, I'm first going to collapse its methods, but you may assume that they're still there. The descriptor that I'm going to implement is the favorite descriptor. The idea is that if I access the isMyFavorite attribute on a specific guitar instance, this descriptor will tell me if that guitar happens to be my favorite guitar. For instance, if I recreate my Warwick instance and then access the isMyFavorite attribute on it, it should return true, as my Warwick bass is currently my favorite guitar. If, on the other hand, I create an instance for my Fender Jazz bass, the attribute should return false, as while this is a very nice bass guitar, it's currently not my favorite. Do note that I've assigned a class attribute to the actual descriptor instance, as this is how descriptors work. They customize how attributes work if you access them via an attribute. I'm not turning the guitar class itself into a descriptor. That wouldn't work. Alright, time to implement the descriptor class, favorite descriptor. Since I only want to do something special when we access the attribute isMyFavorite, I only have to implement one method, a dunder get method. The dunder get method has 3 parameters: self, which refers to the descriptor instance, instance, which refers to the current guitar instance I'm accessing the attribute on, like my Fender or my Warwick, and owner, which refers to the class that owns the attribute, guitar in this instance. Now, remember, I've assigned the class attribute to the descriptor. This means that in theory, I can also access the descriptor directly on the guitar class as guitar.isMyFavorite. Since there is no specific guitar instance in that case, Python will pass none as the value for instance. This is something that I will have to deal with, which I simply do by checking if the instance is none, and if so, by returning the descriptor itself. Returning the descriptor itself is not strictly necessary, but given that I have no other useful value to return, I might as well return the descriptor so you can easily introspect it. If the function makes it past this guarding if statement, I know that the attribute was accessed on an instance. So now I can simply compare the name of the instance to the name of my favorite guitar, Warwick Streamer. Obviously, this implementation is a bit naive in that it assumes that an instance always has a name attribute, but this is obviously just an example. Alright, let's see it in action. First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance to Warwick Streamer. Since the name is Warwick Streamer, we get true. If I now also create an instance for my Fender Jazz Bass, you can see that when I access the attribute on my Fender, the attribute will return false, as the name of this guitar is not equal to Warwick Streamer. Finally, to complete the demonstration, if I access the attribute directly on the class, that is guitar.isMyFavorite, then I simply get the descriptor back. This is because there is no instance of the guitar class here, so Python will pass none for the instance. Which means that the function returns the descriptor itself in the if block that we have. Now, you might think that this is a really simplified example, that the dunderGet method of a function, the one that takes care of the magic of self, is much more complicated than this. In truth, as I'm about to show you, the dunderGet method of a function is nearly identical to the dunderGet method we have here. This is the implementation of the dunderGet method of functions, or well, a pseudo-implementation of the actual get method that was written in C. As you can see, it's nearly identical to what I just implemented for the favorite descriptor. If the instance is none, which happens if we get a function using a class attribute directly, this dunderGet method will simply return self, which here means the function itself. If we access the function on an instance, that instance will be passed as the argument for the instance parameter, which means that we make it past the if statement and then return something that is called a Py method. And this is the bound method we saw earlier. When it gets created, it gets the function as we pass self to it, and it gets the instance as we pass the instance parameter to it. And that is how a bound method already knows which instance it is bound to. It happens when the function is accessed. To show that in action, if I access the playNote method directly on the class, there is no instance, so instance will be none in the dunderGet method, and we will just get the function itself back. This is because accessing it in this way is more or less equivalent to calling the function's dunderGet method directly and passing none for the instance parameter and the guitar class for the owner parameter. Likewise, if I recreate my Warwick instance and access the method on that, we get a bound method back. This is because this is roughly equivalent to calling the function's dunderGet method directly with Warwick as the value for instance and guitar as the value for owner. And this is the magic of self. When you access a function using an attribute, the descriptor protocol takes care of binding the instance to the function in something called a bound method. And functions are not the only descriptors that are built into Python. There are some other built-in descriptors that you've probably already used, potentially without knowing that they made use of the descriptor protocol. I'm going to show you 3 other built-in descriptors that you've probably already come across. First, the class method descriptor, which is often used as a decorator, wraps around a function to bind the class and not the instance to the function. It does this by implementing an alternative dunder get method that binds the owner parameter instead of the instance parameter to the function. One difference with a regular function is that this binding happens both if you access it on an instance as well as when you access it directly on the owner class. Likewise, the static method descriptor also wraps around the function to provide an alternative dunder get method. This dunder get method will not bind anything at all, but will just return the function as is, even if you access it on an instance. And finally, the property descriptor, also often used as a decorator, allows you to easily create getters, setters, and deleters. It does that by calling the methods you specified in its dunder get, set, and delete methods. And with those descriptors, we've come to the end of my talk. To summarize, the most important two takeaways are: 1. Descriptors allow you to customize attribute access, which means that you can abstract away logic behind the normal flow of interacting with attributes. And 2. This is precisely what functions do. They are descriptors that modify attribute access to create bound methods. There are also a number of important things that I haven't covered in this talk. First, I haven't really talked about dunder set and the dunder delete methods. These are important, as the presence of these methods in a descriptor actually influences the lookup sequence Python uses. Descriptors with a dunder set or a dunder delete method are what the docs call data descriptors. A descriptor with just a dunder get method is called a non-data descriptor. Since this distinction can be tricky to get, I recommend you to look it up in a good resource, like Raymond Hattinger's tutorial on descriptors, or in a book such as Fluent Python, which calls them overriding and non-overriding descriptors. Finally, I also haven't mentioned the dunder set name method. While this method is technically not a part of the descriptor protocol, it is often used within descriptors to get access to the name of the attribute that was assigned to the descriptor. I'd like to end my talk with a quote from Lee Siegel. "I'm writing a book on magic," I explain, and I'm asked, "Real magic?" By real magic, people mean miracles, thaumaturgical acts, and supernatural powers. No, I answer, conjuring tricks, not real magic. Real magic, in other words, refers to the magic that is not real, while the magic that is real, that can actually be done, is not real magic. There is a lot of magic in Python, and some of it is of the deeply arcane kind that we, mere mortals, cannot really touch, as it's hidden away deep in Python's internals. At the same time, most of the magic in Python is of the kind that we can use, that we can hook into. In this talk, I've zoomed in on a particular piece of magic, self, but I would like to challenge you to go out there and dive deeper into Python's data model, to discover even more magic and to use that magic to create meaningful abstractions and objects that behave just like Python's built-in objects do, to provide the users of your code, including yourself, with a high-level interface that is familiar and that makes sense. So, go out there and practice magic. With Python, we can all be magicians. This is it. I hope you've enjoyed it. If you want to take another look at the slides of this talk, you can find them on my website, sebastiaanzeeff.nl. You can also follow me on Twitter or connect with me on LinkedIn. You can also often find me on Python Discord as Sebastiaan. In any case, thank you for your attention, and I hope that you'll enjoy the remainder of Pyjamas.
Okay, so we are back, and Jacob's still here. Do you want to go on stage? I'll put you on stage. I'll force you on stage. Hello.
Oh, sorry. I pressed the button the same time you pressed the button.
Yeah, I'm sorry about my light. I'm a bit strange because I now have a light that's look like a sun. It's on my table, so that's why it's a bit weird. It's like, I'm roasting myself. But yeah,
I got a light too. It started getting really dark because the light's behind me, and then I looked at my first talk and I was really dark, so I just got a light out and I was like, you know what? I definitely, yeah. But
I
all
thought it's
right,
window.
so yeah, it is a window, but then I need a
I
light
see.
in front of me because otherwise the light comes from behind.
Ah. Then yeah,
Yeah.
you look like
Like
you
it,
are kind of like
yeah.
I don't know, like cinematic, isn't it? Like
Like a halo coming from behind me. Yeah,
yes.
it's quite funny. Like I saw my first talk and I was about to laugh. I was like, how did people get through this without looking at me and laughing? So yes, I will refer back to the old talk, and yes, magicians we will be. What an incredible talk on the powers of self in Python. I'll transfer the mic back to you now. So everyone, please take care, stay safe, and we'll have an incredible pajamas.
Yeah, thank you, Jacob. Now I'll let you take a break. If you want to come back
Yeah,
anytime, I'm happy to have you back.
I
Because
will. I
is
will.
it?
I
Yeah,
will
sure.
try to show up for the lightning talk with you guys.
Oh, great, great. Love that, love that. Okay, I'll see you in a bit, so you can
Sure,
prepare your lightning talk or whatever. Do
I will.
your thing.
Right.
So we are at the final mile, final stretch towards the end of the conference. So if you look at our schedule, we'll have other amazing talk coming up. Which is, do we have the thing here? I'm so unorganized, unlike Jason earlier, that he have everything planned. I'm just like, where is it? Oh, someone already put it up. Great. So yeah, we have so it's a securing Django applications here. So this will be the next one. Is coming up in a few minutes, and then we will have a few speakers to come up to talk about GitHub Action. Oh, I love GitHub Action. I use GitHub Action myself, and I'm kind of addicted. And we have a mysterious talk, counting ships. I hope you don't fall asleep. I don't know. Maybe I would fall asleep. I don't want to because I still have other talks to host. We still have this decision tree visualization. Decision tree again, like very close to my heart because I was a data scientist, so I used decision tree a lot in my past time. So also type hinting, something that I really like. Also, it's kind of nice to close with the last talking about type hinting because our keynote speaker, like around 20 hours ago, talk about type hinting as well, talking about like that's something that she liked about Python. So yeah, so it will be interesting to if you don't know what is type hinting, it's time to jump in and learn about it. So and also we do have great stuff. So yeah, there's like all this stuff is like we have links for joining the Discord, also joining the lucky draw for a free book, and then also give a lightning talk is really good. It's like only 5 minutes. You don't even need to prepare the slides. You can just like, I give you 5 minutes, you do whatever you want, and then everybody's gonna see it. It's gonna be on our Pyjamas YouTube. Yeah, you get publicity. So yes, lightning talk at 7 UTC, so a few hours from now. Right, so without further ado, I would just like maybe give a chance to show you what our sponsor want you to know. There are some freebies there. And then I would actually play the talk submitted by our next speaker, Gajendra, talking about securing Django applications. But first, a few words from our sponsors.
Hello everyone, my name is Gajendra Deshpande, and today I will be presenting a talk on securing Django applications. So in today's talk, I'll be discussing about security aspects of Django web applications, but web applications in general, Django applications in particular, penetration testing of Django web applications, overview of OWASP top 10 risks, Django Hunter and Django Goat applications, then strategies and configuration settings to make Django applications secure. So we will not be discussing these things in a sequence. So we will discuss the issue and its solution. So there is a very good website. You can check it out. That is djcheckup.com/pony. So you can just specify your Django site's URL and click on run a checkup on my site button. So it will show the vulnerabilities on your Django site. So say for example, we have checked, we have used this DJ checkup tool for checking the vulnerabilities present on a particular Django website. So now you can see here that it is showing thumbs up symbol. That means these issues have been taken care. But if you see the thumbs down symbol, that means you have to take care of that vulnerability. So next is, so on this slide, you can see here the structure of Django code. Now here, you can see here that there is a code which has been included in the red rectangle. So now there are two things. One is you have to keep your secret key secret, which is very, very important. So especially for the production environment. Then second one is you need to set debug flag to false. So this can be very useful only at the development stage. But when you go for production environment, when you deploy your application, you need to set it to false to hide the errors, because errors also disclose some information related to the system and which can be used by the hackers to carry out the further attacks. Now these are the top 10 OWASP vulnerabilities. So we have OWASP vulnerability as injection vulnerability, then broken authentication, sensitive data exposure, XML external entity, broken access control, security misconfiguration, cross-site scripting, insecurity serialization, using components with known vulnerabilities, insufficient logging and monitoring. Now, if you look at these vulnerabilities, these can be grouped into several categories. So some are related to the vulnerable code. So you can go to the source code and fix it in the source code. Then some are related to configuration settings. So if you make misconfigurations, then again, it may be problematic. Then some are related to logging and monitoring. Now let us first discuss the injection attacks. So there are various types of injection attacks. SQL injection is one of them. It's a type of attack where malicious user is able to execute arbitrary SQL code on a database. So this can result in records being deleted or data leakage. So injection vulnerabilities are often found in SQL, then it can be LDAP. LDAP is related to authentication. Then XPath injection, where XML can be the data source instead of database, or even no SQL queries. Then operating system commands, XML parsers, and so on. So injection attacks can result in data loss, corruption of the data, or disclosure of information to unauthorized parties, or even loss of accountability and denial of access. So it can sometimes lead to complete host takeover. So how it is written, how it is carried out. So you can see here that a query has been written in red color. So that's how the attack vector is appended at the end of valid URL. So you write a query, string query is equal to select star from accounts where customer ID is equal to plus request.get parameter of ID. So this is a valid code which you have written in your source code. Now this can be accessed using the URL mentioned below, that is http example.com/app/view, then ID is equal to. So you can note here that after ID, the attacker has added the attack vector, that is or1 equal to 1. So he is using Boolean operators. So in this case, whatever may be the left hand side query, it will result into disclosure of all the information in the database. Okay, so what is the solution? Okay, so solution is to go for query parameterization. Now Django also provides two functions, one is extra and second one is raw SQL. So which enables the developer to write custom queries in Django. So that is, if you want to bypass query parameterization, then you can go with extra hand raw SQL. So how you can protect yourself from SQL injection attacks? So first one is go for query parameterization, which is by default enabled in Django. Then whenever you are using extra and raw SQL functions, use them with caution. So that means you have to use them when they are really required. Then use positive or whitelist server-side input validation. So it may not be the complete defense. Then second one is broken authentication. So attackers have access to hundreds of millions of valid usernames and password combinations for credential stuffing, default administrative account lists, automated brute force, and dictionary attack tools. So session management attacks also come into broken authentication. Now, here the intelligent thing what attackers do is they have to gain access to only few accounts. So they need not have to gain access to all the accounts. If they get access to just the admin account, then they can compromise the entire system. So in general, this will be the goal of hackers, to gain access to the admin accounts or super admin accounts. The next is credential stuffing, the use of list of known passwords, and it's a common attack. Then most authentication attacks occur due to the continued use of passwords as a sole factor. So you have to use additional security layer. So to protect against broken authentication, wherever possible, implement multi-factor authentication. Okay, so you can enable two-factor authentication. That is one solution. Second one is use authenticator apps such as Google Authenticator or Microsoft Authenticator. Okay, then second one is, then third approach is to use single time login or one time login. By using these things, you can actually take care of broken authentication protection. Then broken authentication. Then do not ship or deploy with any default credentials. So particularly for admin users, that is because the end users, they tend to use the default passwords only. Generally, default passwords are standard passwords and they can be easily guessed by the hackers. Then implement weak password checks, such as testing new or changed passwords against a list of top 10,000 worst passwords and so on. Then ensure registration, credential recovery, and API pathways are hardened against the account enumeration attacks using the same messages for all outcomes. So that means don't use the default settings, always customize the settings. Then limit or increasingly delay failed login attempts. So log all failures and alert administrators when credential stuffing, brute force, or other attacks are detected. So in case of Django, you have got some packages which you can use and you can protect yourself against the broken authentication. So you can use one-time passwords for Django, then you can use two-factor authentication for Django, and also you can go for Django user session management. Then third one is the sensitive data exposure. So here in this case, what happens is rather than directly attacking crypto, attackers steal keys, execute man-in-the-middle attacks, or steal clear text data of the server while in transit or from the user's client, for example, the browser. So a manual attack is generally required here. So an application encrypts credit card numbers in a database using automatic database encryption. However, this data is automatically decrypted when retrieved, allowing SQL injection flaw to retrieve credit card numbers in a clear text. So one thing what happens here is the moment the information is decrypted, the information is available in the plain text. And if the device is compromised, then automatically, if the spywares are installed, then the information can be directly accessed by the hacker. So there's a solution for it. There are some advancements in the cryptography field. For example, homomorphic encryption, which helps you to perform computations on the encrypted data. It's also known as confidential computing. Okay, so a site doesn't use or enforce TLS for all pages or supports weak encryption. So always enable SSL, that is secure sockets layer. So the solution are that a classified data processed, stored, or transmitted by an application, then identify which data is sensitive according to privacy laws, regulatory requirements, or business needs, then apply controls as per the classification, then don't store sensitive data unnecessarily, discard it as soon as possible, then make sure to encrypt all sensitive data at rest, then ensure up-to-date and strong standard algorithms, protocols, and keys are in place, and use proper key management solutions. Then encrypt all data in transit, that is enable HTTPS or HSTS, then disable caching, then store passwords using strong adaptive and salted hashing functions. Then if you are using Django, then you can make these settings in production.py file. So you have to enable these options to true, and you have to mention the protocol as HTTPS. Then you can use additional modules available in Django for cryptography. For example, you can use Django encrypted model fields. Then you can also go for wrapping the Python. You can also go for Python cryptography library, or you can use Django for net fields for additional encryption features. The next attack is the XML external entities attack. So attackers can exploit vulnerable XML processors if they can upload XML or include hostile content in an XML document. So exploiting vulnerable code, dependencies, or integrations. So these flaws can be used to extract data, execute a remote request from the server, scan internal systems, and so on. So this is the example how attacker can perform external XML entity attack. So entities in markup language, maybe in case of HTML also, these are the special symbols which will be displayed on a web page. Okay, so there is a syntax to access or print any HTML entity. Say for example, if you want to print copyright symbol, then you have to write ampersand copy and the semicolon. So this syntax you will see here on this slide. Say for example, here XXE is the custom entity. So XML's greatest feature is that it allows you to create your own elements, it allows you to create your own attributes, it allows you to create your own entities. So now in this case, what is happening is you can create a custom entity called XXE, and note here that how it is accessed, ampersand XXE and semicolon. But the thing here is the custom entity XXE is linked to /etc/password file. So the moment you access this entity, it's going to reveal the content of /etc/password file if there are appropriate permissions. Then an attacker can also probe into server's private network by changing the entity line into the appropriate IP address and the URL. So here XXE is mapped to the IP address 192.168.1.1/private. Then attacker can also link XXE entity to some random file, which is potentially endless file, which results into denial of service attack. Now the solution is, wherever possible, use less complex data formats such as JSON. So JSON stands for JavaScript Object Notation. So now we are seeing the replacement of XML everywhere with JSON, and also avoid a serialization of sensitive data. Then disable XML external entity and DTD processing in all XML parsers in the application. Then again implement whitelisting, server-side input validation, then filtering or sanitization to prevent hostile data within XML documents, headers or nodes. Then verify that XML or XSL file upload functionality validates incoming XML using XSD validation or similar. Now, when you are working with XML and when you are using standard code editors or IDE environments, you will find these validators. So use those validators. You can use those validators against the DTD. You can use the validators against your XML schema file or XML syntax. Then you can also use a shadow daemon, which is a collection of tools to detect, record, and block attacks on web applications. So technically speaking, Shadow Daemon is a web application firewall that intercepts requests and filters out malicious parameters. It's a free software and it supports Python, Django, and Flask, and it also supports PHP and Perl scripting languages. Then next is the broken access control. So here the application uses unverified data in a SQL call that is accessing the account information. Say for example here the statement is written, so p statement dot set string 1 comma request dot get parameter of account, then results is equal to p statement dot execute query. So an attacker simply modifies the account parameter here in the browser to send whatever account number they want. So in this case, instead of account, he's saying not my account. So not my account is the indication for the account number which is not existing in the database. Okay, so an attacker can simply force browsers to target URLs. Okay, admin rights are required for access to the admin page. But if it is unauthenticated, then user can access the one of the above pages, and because it is unauthenticated, it's a flaw. So any non-admin user can access the admin page. So in this case, it will be a broken access control vulnerability. So to protect against the broken access control, the access control is only effective if it is enforced in a trusted server-side code or serverless API. Okay, where attacker cannot modify the access control check or metadata. Then disable web server directory listing and ensure file metadata and backup files are not present within web roots. So the one more thing what you can do is don't store files in the default location. Always customize it. Then log access control failures, alert admins when appropriate. Then for this, you can also use a Django module called as Django user management. The next is security misconfiguration. Your application may be secure, your application code may be secure, but if it is wrongly configured, then again your application becomes vulnerable. So attackers will often attempt to exploit unpatched flaws or access default accounts, unused pages, unprotected files and directories, etc. to gain unauthorized access or knowledge of the system. So security misconfiguration can happen at any level of application stack. So including network services, platform, web server, application server, database, frameworks, custom code, and so on. So the application server comes with a sample applications that are not removed from the production server. So if you don't remove it, then it will become vulnerability. Directory listing is not disabled on the server. So these are the some examples for security misconfiguration. Then the solutions for security misconfiguration are that go for Django hardening. That is, don't use any default settings, any default location, any default parameters. So always customize it. Then disable directory listing. Then use automated scanners to detect the vulnerabilities. Then customize error messages to hide sensitive information. This is very, very important because if you don't hide the system error messages, then these error messages will reveal some information related to the operating system or a browser. If that is revealed, then that can be easily used to carry out the further attacks. Then next is cross-site scripting. So here the application uses untrusted data in the construction of the HTML snippet without validation or escaping. So for example, you can see here the HTML code is written and the attacker is trying to execute a function. Okay, say for example, there will be a user interface to search. Then instead of searching keywords, the attacker can simply write JavaScript code, say for example, alert box, and when he clicks on or when she clicks on search button, instead of searching it, it will execute alert box if that vulnerability is not taken care of. So in this case, the attack causes the victim's session ID to be sent to the attacker's website and allowing the attacker to hijack the user's current session. So here session hijacking is carried out. Now attackers can use cross-site scripting to defeat any automated cross-site request forgery defense. Then to protect against cross-site scripting, you can use Django templates. So Django templates protects you against the majority of XSS attacks, but there are some exceptions. For example, you can see the code style class is equal to, in double curly braces, some code is written. So malicious code can be included in this section. So Django templates will not protect you against such types of attacks. So it is also important to particularly careful when you are using is safe and mark safe tags. Then you should also be very careful when storing HTML in the database, especially when that HTML is retrieved and displayed. The next attack is the insecure deserialization. So here applications and APIs will be vulnerable if they deserialize hostile or tampered objects supplied by an attacker. So this can result into two primary types of attacks. One is object and data structure related attacks, where the attacker modifies the application logic and achieves the arbitrary remote code execution if there are classes available to the application that can change behavior during or after deserialization. Then second one is the typical data tampering attacks, such as the access control related attacks, where existing data structure are used but the content is changed. So this serialization may be used in applications such as remote process communication or inter-process communication, wire protocols, web services, databases, HTTP cookies, and so on. Then to protect against insecure deserialization, the only safe architectural pattern is not to accept serialized objects from untrusted sources. So you need to verify the source. You need to ensure that the serialized object is from the trusted source, or to use the serialization mediums. Then implement integrity checks such as digital signatures. For that, again, Django JSignature module is available and you can use it. Then enforce strict type constraints during deserialization before object creation. Then isolate and run code that deserializes in low privilege environments. Then log deserialization exceptions. The next vulnerability is using components with known vulnerabilities. So component heavy development patterns can lead to development teams not even understanding which components they use in their application or API. So whenever we are developing web applications using platforms like Django or Flask or even WordPress, we tend to use third-party components heavily. And if we see by design, Django is secure. By design, WordPress is secure, but the components are not secure. These modules or additional plugins are not secure because the developers of these modules or plugins may not be aware of secure coding practices. So if the component is vulnerable, then hackers will get the backdoor entry into your application. Then to protect against this vulnerability, that is components with known vulnerabilities, there should be a patch management process, so which can remove unused dependencies, unnecessary features, components, files, and documentation. Continuously inventory the versions of both client side and server side components. Then they can perform dependency check, etc. Then only obtain components from official sources over secure links. Then use tools like Shodan and Django Hunter. The next is insufficient logging and monitoring. So in this case, we know that there are going to be failures, there are going to be attacks, and these attacks needs to be logged. If they are not logged and if they are not monitored regularly, then there will be a problem, because we will not be able to determine where the problem is, and we will not be able to patch those things. So that's why there should be sufficient logging and monitoring tools in place. So to protect against insufficient logging and monitoring, ensure all login, access control failures, and server-side input validation failures can be logged with sufficient user context to identify suspicious or malicious accounts. So basically, you need to log everything with details. There are tools which will help you to do that. Then next, let us see some applications which will help you to identify the vulnerabilities and learn vulnerability analysis with respect to Django applications. So there's an application called as Django Hunter. It's a tool designed to help identify incorrectly configured Django applications. For this, you need to have a shodan key. Then it works with Python 3. The code can be found out in the repository mentioned on this slide. You also need Google Docs. So you need to mention the Google Docs such as disallow host, key error, operational error, and so on. And it can identify the vulnerabilities present in the Django applications. So if you are really interested to learn more about Django security testing, then you can go for Django Goat applications. So basically there are Goat applications which can be used to run which can be used to learn security testing. So they are all intentionally vulnerable applications. Then Django security resources, you can visit these URLs. Then Django's security documentation is really nice. You can visit this official documentation for more information. So in summary, since Django is a web framework, it maps to OWASP top 10 vulnerabilities. It has built-in modules to build secure Django web applications. Security of the application and data is not only the responsibility of the developer, the user is also equally responsible for the security of the data and accounts. So thank you everyone for attending my talk.
Okay, so that was great. And then up next, we would have, we'll have our speaker talking about using GitHub Action. We all love GitHub Action. So up next we'll be there. So before that, we would have a few minutes. So just have a look at our sponsor, what they have to get. They have some giveaway, which is amazing. So we'll have a look at that, and then when we come back, then we would start introducing our speaker. Yeah. Okay. Okay, so yeah, let's we're back. First of all, let's introduce our next speaker, Harsh. Hello, Harsh.
Hi,
Hello.
I
Hi.
hope you're doing good.
Yeah, you're doing good. Good. So yeah, it's like we save all the good talks at the end actually. So I really want to hear what you talk about GitHub Action, because I love GitHub Action myself. So really looking forward to that. So when you're ready, and then I will put
Yeah,
your screen on stage. Okay.
yeah, I'm ready right now.
Okay, let's go.
Sure. Okay, I hope my entire screen would be visible right now. So yeah, so hello everyone, my name is Harsh and I will be presenting a talk on using GitHub Actions for your Python projects. So if you have never came across GitHub Actions before, or you're just planning to use GitHub Actions right now to basically automate your entire build, test, and linting process, this talk is entirely for you. So before I jump into my talk, I would like to extend my heartfelt gratitude to the team at Pyjamas for providing this great opportunity. So as the very name suggests, GitHub Action is a feature that is offered by GitHub itself to enable continuous integration and continuous deployment capabilities in your project. And it has been in the scene for the past few years. The community is going great. And a lot of the open source projects have started migrating their CI/CD build tools from some existing tools like Circle CI or Travis to GitHub Actions. And we will be just exploring like a few things about GitHub Actions, what it exactly does, how we can write a very simple workflow file for our CI process, and what are the various toolings and some best tips and tricks that you can use while building your workflows using the GitHub Action. So before we get started with the whole thing, let me introduce myself. I am Harsh, and currently I'm working as a software developer at Quanset Labs. Over there, I work with some open source projects like QHub, which is an automated data science platform, and I work with SkyPy, which is a library for mathematical and statistical computing. I was a Google Summer of Code student at Metacall. Metacall basically provides a code library through which we can make inter-language function call. And I'm also Google Season of Docs technical writer and outreach mentor at Moja Global. So if you'd like to connect with me and know more about me, you can find me on harshcasper.com. And let's get started now. So the agenda for today's talk is very, very simple and it's very flexible. First off, we will be understanding a bit about CI/CD, what it exactly does, and why is it so important for us in the whole DevOps lifecycle. We will also explore a bit on why is it like, what are GitHub Actions and why is it so important, and what it exactly does. We will also explore a simple workflow that I wrote for a few of my personal projects. And we will also write a very simple workflow file for GitHub Actions so that we can basically install, test, and lint a simple Python Flask application. Uh, all of this, we will then jump into how we can run our GitHub Actions locally, because this is very important for a lot of developers to find out on how they can make sure that there doesn't seem to be any issue, that there doesn't seem to be any problem with your workflows. And lastly, we will explore some extra toolings through which you can have your own self-hosted runners, how you can use the marketplace for GitHub Actions in a very efficient manner. And for any questions or concerns, you can simply use the chat to put them out. And I will take all of the questions at the end of the session. So let's get started. So what exactly is CI/CD? So CI/CD is just a method in the DevOps lifecycle through which we frequently deliver apps to our users by introducing automation in the various stages of the development. So the CI pretty much refers to the continuous integration right here. And I hope like most of you already know that continuous integration simply means that the new code changes are continuously built, tested, and merged to the repository where all of the developers can collaborate. The CD, on the other hand, refers to the continuous delivery or the continuous deployment, like which are quite interrelated concepts, but they are often used interchangeably. So both are about automating the further stages of the pipeline, but they are sometimes just used separately to illustrate how much automation is happening. So continuous delivery can simply mean that a developer's changes to the application are continuously tested for bugs and for issues, and then they can be directly deployed to a live production environment. Continuous deployment, on the other hand, simply means that we are releasing a developer's changes from the repository to production where it is usable by the consumers. Now, why is CI/CD so important right now? So in modern development, the goal is to have multiple developers working simultaneously on different features of the same application. Through CI/CD, we basically mitigate the merged issues by having a simple workflow where all of the changes can be simply validated by automatically building the application, testing it out, and by running different levels of automated testing, linting, unit tests, integration tests, and more, so that we can be ensure that none of our changes are breaking the application. A proper CI/CD pipeline makes it easier to continuously receive and incorporate feedback from the rest of the team. And we also make sure that wherever testing fails in an entire CI/CD workflow, we can immediately have a channel through which we can quickly report the failures to the developers. So apart from all of this, CI pipelines also make it easier so that we can integrate third-party toolings and automate some of the manual processes. Like if you need code quality analysis, if you need some linting analysis, you can simply use some plugins or some third-party applications for it. And you can employ a lot of different toolings out of it. Like you can find security vulnerabilities, you can find the other issues in your code base, and much more. Now, there are various CI/CD toolings available in the market. Like some of them have a hectic pricing plan, while some of them offer their services quite generously free. So Travis CI and Circle CI is like one of the most popular continuous integration services out there. And it is like basically used to construct and test projects. And it can automatically detect new commits in your GitHub, or maybe if you're using some other Git-based provider like GitLab, and it can simply build out your changes. We also have AppVior and we also have GitLab CI, both of which are designed to handle like different aspects of software development lifecycle. So you can use commits to trigger builds, run the events, run the tests, and also deploy your code. We also have some other toolings which are quite popular, like we have got Jenkins, we have got Bamboo that I have not discussed here, since our main focus would be entirely on GitHub Actions. So what exactly is GitHub Action? So as I mentioned earlier, GitHub Action is a simple framework that allows automation of your software development workflows. And this is entirely accomplished by using event-driven commands. So, and it can be triggered to execute a specified event. These triggers can be a simple creation of a pull request, or it can be a push to the main branch of the repository. It can be putting a label on a specific pull request, or it can be like tagging a new release. So GitHub Action is a native CI/CD that is offered by GitHub, and we can use it for building, testing, deployment, and much more. And this is very, very similar to what GitLab did with GitLab CI when it had its inception. So if you combine this with the Git-based repository that is provided by GitHub, and also the GitHub Container Registry, GitHub is certainly looking to centralize all aspects of the software development under a single big umbrella. So right now, the pricing for GitHub Actions is very, very generous for open source projects. For open source projects, it is entirely free. But if you are someone who is collaborating in a small team, or maybe a part of an enterprise, you can certainly look at the billing for GitHub Action on the official docs. But as you can see, like it might just take you around $0.008 US for every minute it runs, which is quite cheap. For Mac OS and for Windows, it is slightly more expensive, which is quite understandable as well. Lastly, GitHub offers a great marketplace where you can find custom applications and actions that you can particularly use in your workflow. I'm going to just demonstrate how you can do that. But right now we have like almost over 10,000 marketplace applications that you can use for different kind of purposes. If you want continuous integration, if you're looking for deployment, if you're looking for localization, we almost have an action for each and everything. You can also make an action yourself if you have a particular need for it. So this is an example workflow that I have right here, and it has been picked from one of my personal projects. So if I just go to .github and I go to workflows, so you can exactly see what I'm doing right here. So I have a very simple Python library that allows us to basically statically analyze our web page and our websites and provide us immediate optimization recommendations. And we have a simple workflow file that basically runs on the Ubuntu latest. It has a matrix. Matrix simply means that we can test our whole application on multiple different operating systems and the Python versions or any other dependencies in a continuous manner. So we are testing this application on Python 3.6, 3.7, 3.8, 3.9, and we are running this on our Ubuntu latest. This particular workflow is triggered only when we have a push to the main branch or when someone is creating a pull request to the main branch. So as you can see, the workflow is very simple and it is very readable as well. The very first thing that we see is that we're using the checkout action, which is an officially supported action offered by GitHub, through which we can set up our Git repository on a new workflow runner. We also have setup Python, where we basically set up Python for our incremental workflows. So this action will basically set up individually all of these Python versions that are specified here: Python 3.6, 3.7, 3.8, 3.9. We're also going to upgrade the pip version so that we can mitigate those regular Python warning issues. And then we are going to install all of the dependencies. We are going to build the application. We are going to test it using nose tests. And finally, we are going to lint the whole code base to see if we have got any stylistic issues or not. So this is exactly very readable. And the best part about this is we can easily integrate more actions to our project by simply using this interactive dashboard. So we can just say new workflow, and GitHub Actions will automatically suggest all some of the workflows that we can use. So we can use a Docker image workflow, we can use a Python package using Anaconda workflow, or we can deploy our code to some of the popular services. This is not exactly needed here because we have not built a full stack service. We have just a simple Python library that is being deployed to PyP. So why should you exactly use GitHub Actions after all? There are various reasons for it. The first one is that you can capitalize on a wide number of operating systems and architecture. So as you might have seen on the billing itself, we are getting access to Linux, Mac OS, and Windows, all of them in a single CI service. So you don't have to scatter your CI services across multiple different CI toolings. You can also capitalize on a wide number of architecture. If you want to build on 64-bit, if you want to build on R64, if you want to build on PowerPC, GitHub Actions certainly has got actions that allow you to do so. Next is GitHub Action has a plugin-based architecture. So plugin-based architectures in the sense that you can simply use the third-party actions that are created by some other users, and you can simply integrate them into your workflow. So let us say that you want to have an action that automatically builds your site and deploys it to GitHub pages. You can easily find an action that exactly does so with your exact configuration. Maybe you want to have something that deploys your pull request to some sort of a static site generator, let's say search. We have an action for that. Let us say you want to test your application, test your whole website on Lighthouse CI. We have an action for that. So all of these is basically incorporated into the plugin-based architecture, and it is literally as easy as to copy paste the official snippet, and you will be ready to go. Third, GitHub Action has an ease of development. So you don't have to literally spend a lot of time writing your workflows and customizing it. You can consider all of these simple commands to be very, very similar to how the bash commands look like. And you just need to specify the things right here. And if there is any issue, GitHub has got a lot of third-party toolings through which you can debug your workflows quite easily. I will come on that part later. And lastly, you can also create your own action. So if you have some specific idea in your mind that you want to capitalize upon, you can create your own action for some specific use cases. You can also emulate your entire workflow locally by using a tool that I'm going to discuss later. And you can also host your own runners. So maybe if you have some different requirements and GitHub Actions is not sufficient to fulfill that, you can simply create your own runners and you can run your GitHub Actions on that runner itself. And you have to just pay for the runners that you're running. So we will be writing a simple workflow right now. And this is a very simple stuff. So we have just a simple Flask application. And what we are going to do is we are going to set up Python on a GitHub runner. We are going to install the project along with all of the dependencies. We are going to run the tests. We are going to lint the code. And finally, we are going to build the docs. So I hope my VS Code would be visible to everyone. So as you can see, we have, I have just kept all of my slides right here, which is built in Django. But rest of our Python code is pretty much kept in this app.py file. And I also have got some basic tests, which just tests the root. And it basically sees if the status code is 200 and if I'm getting the expected JSON response. I have also a docs. So this docs is essentially just capturing my application docs right here. And it is pretty much doing all of the things that I'm expecting it to do. So if I just run Python 3 app.py, I can exactly see that, okay, maybe my code is still occupied. So as you can see, my application is running right now. I can simply go and check out Hello World right here. If I need to just go overhead and I just need to do my tests, I can simply specify PyTest, and all of the tests are passing. I can also do a simple docs build, and I can simply go to the build directory right here. And I can find that my docs are pretty much kept here. So what we just need to do is we just need to create a workflow which exactly installs all of the dependencies, which tests our application and which links the code. And finally, we can also build the docs as well by using a third-party workflow. So to do that, the first of all, we are going to create a .github directory. So .github basically specifies all of the GitHub specific files. So you can keep it to use your issues and the pull request templates. You can have your workflow files right here, and it is pretty customizable as well. Within .github, I'm going to create another directory, which is a workflows. And this is exactly where all of my CI/CD workflow files can be kept right here. And finally, I'm going to create ci.yaml. You can name it anything. It can be main.yaml, it can be ci.yaml, it can be flask.yaml. So the very first thing that we are going to do is that we are going to specify the name of our workflow. So here, the name would simply say flask ci. And then we need to specify on where exactly do we need to run it on. So I want to run it on push and the pull request events. And as you can see, my GitHub Copilot is automatically suggesting me stuff. So I can easily say that I want this workflow to run only on master. So every time someone makes a push to the master branch, or if someone is making a pull request to the master branch, this is exactly where I'm going to create it. You can also specify this as a list. So if you're making your PR, or if you're making your commit to a lot of different branches, you can simply specify that right here. So next, we're going to specify a jobs. And job is basically, it can be just thought of as an entire workflow. So every time we are running a job, it will set up our whole project on some specific operating system. It is going to create a strategy for us if you want the same. And you can simply get started with writing all of your steps right here. So my GitHub action is automatically suggesting me a few things, but I'm just going to delete a few parts. And I'm going to specify a strategy as well. So this strategy basically signifies on how many different things that we want to build it on. So let us say that if you want to have something let's say, Python version. So you can easily say Python version, and you can specify a list right here that says on how many different parts that you exactly would like to build. And this is super easy right here. So next off, we are going to do the steps, and this is exactly where you need to specify the steps so that you can run your workflows. So you can see that the first step that we are going to do is we want to have the checkout, and this basically sets up our entire thing on the GitHub runner that we are going to use. The next is we are going to use the name part, and this name is where we are going to set up the Python. So this Python is exactly going to correspond to the strategy that we have right here, and we are going to use the setup Python action. And you can easily specify the Python version right here. So you can either specify a strategy by specifying a list, or you can simply specify the Python version itself. For now, I'm just going to remove it because we don't exactly need to test it on multiple different Python versions. Once you have done that, you can simply specify that you want to install the dependencies. So you can simply say that pip install -r requirements.txt. You can also upgrade your pip right here. So to do that, you can just simply say Python m pip install. And I can say I want to upgrade my pip itself. I don't need to upgrade my setup rules and wheel. And once we are done all of this, we can simply say we want to run the tests. And to run the test, we can simply specify that we want to run the PyTest. And we are simply done with our workflow. So you can easily go ahead with it. And if you just have a look, it is very, very similar to what we have right here. Okay, I guess I missed the indentation part. So I'm just going to indent it. So we have our entire workflow right here, and I hope this won't create any issues. So maybe I can just go ahead and I can simply say that I want to commit this. And if I just jump back to my repository right here, that might have triggered a workflow. And as you can see, like this is denoted in an orange color. So you can easily check that our workflow is running right now, and it is going to build the whole thing right here itself. So some of the things are already done. The checkout is complete, dependencies are being installed. And once that is done, we can like simply run the tests, which is pretty much successful. Our tests have passed and our workflow is pretty much running right now. So what if you want to like integrate different parts to it? Like let us say we want to run flaky as well. So we can just simply say like run flaky8, and I can like simply say flaky8, but before that I need to install flaky itself. And once we have done that, I can again say git add, git commit, and I can push it back. So if you just check this right now here, my workflows are triggered once again, but this time we have an additional step. And this additional step is to basically run flaky8 right here. So this basically shows like how you can basically write a simple workflow. If you have like additional parts to it, like maybe you want to integrate MyP, or maybe you're using Poetry for installing the entire thing, you can like have your custom actions for it. And this is where the GitHub Marketplace basically comes handy. And as you can see, like the entire workflow is successful right now. Flaky has not reported any issues, and our tests are running as well. So you can also like write more complex workflows. Maybe you want to deploy an entire application on a Kubernetes cluster, or maybe you have a Docker-based setup. You can simply configure that using your GitHub action itself. If you want to like run your GitHub actions locally, this is where we have a tool called as the Act. So Act is basically offered by NetOS, and it basically allows you to run your GitHub actions locally. And it can be simply installed using your favorite package manager. And this is like how you can easily configure to run Act on your local machine. Since I'm using a Mac, Act is not like very supported here. But if you're using a Linux-based operating system, you can simply use Act to like start testing out your workflows. So Act has a very handy command line interface, and you can use it to emulate your workflows locally. There are only a very few CI services that have their own way of emulating the workflows. And Act basically does it by having something of a Docker-based setup, and it can pretty much like support only the Ubuntu-based workflows right now. It has no support for macOS or Windows-based workflow as of now. So if you're using GitHub Actions very extensively, you can simply use Act to make sure that you're running your workflows locally, and such that it doesn't occur like a lot of noise on the GitHub Actions. Because if the whole CI is failing, it will just generate a lot of warnings, and you will be getting a whole lot of mails from GitHub saying that your workflow has failed. So this pretty much picture shows like how this Act works. And right here, like I'm building SkyPy on GitHub Actions using Act. So SkyPy is currently migrating its build system from the setup tools to Meson. And since we wanted to like test our workflows in a very consistent manner, and this is why we just capitalize on using Act right here. You can also use self-hosted runners. And since GitHub Actions are pretty much great, but if you're working with teams which work privately as well, the free tier of just 2000 minutes per month in private repositories can simply run out very quickly. And you need something much better for your entire CI/CD pipeline to run frequently. So you might also need some sort of an extra purpose job. Like if I take an example, you have a project that requires GPU for some of the tests, and GitHub Action doesn't offers like native GPUs for your workflows. So you definitely want to go with something that can exactly mitigate these kind of requirements. So GitHub Actions basically offers self-hosted runners, and you only need to pay for the server that you have right here, but you don't need to pay anything for using the GitHub Actions itself. So you can use like self-hosted solutions so that you can have much better control over your hardware, your operating system, your software toolings. It can also be integrated with the other toolings that is already offered by your cloud providers. So you don't have to like think a lot about having some third-party actions for your purpose. And as I said before, it is free to use with GitHub Actions, and the only payable cost is against the server use. And if you want to have an example of a managed self-hosted runner for GitHub Action, you can definitely have a look at Siren. Siren is entirely free for open source, and there is some generous pricing plan for the private repositories. But you can simply use Siren to use multiple services like AWS, Google Cloud, or DigitalOcean or Azure, so that you can start running your self-hosted runners on GitHub Action itself. Or there are various other open source projects that allows you to do so. So you can definitely have a look at it, and you can definitely have a shot at running your self-hosted runners. And finally, we have got the GitHub Action Marketplace. So as I mentioned before, the whole marketplace is a great way to find some third-party applications or some third-party tools that you would like to use. Like, let us say I want to build my docs as well. This is an entirely tricky thing, and I don't want to cd into a lot of directories and do all kind of commands. So I can just look for something called as Sphinx build, and let me see what I have got right here. So as I can see, I have got an action called as a Sphinx build, and it is publicly offered. So I can just go overhead and I can see how we can write a simple workflow. So as you can see, I just need to drop in this particular line, and I need to specify my docs folder, and I'm pretty much done right here. So I can just copy this. I can go back to my VS Code, can indent this part, and this should do right now. So what I can do is I can say git add, git commit, add docs build. I can do a git push origin master. So as soon as I do that, if I jump back on my repository, I can easily check that my workflow has been triggered once again. And this time there would be an additional step, which is to build the docs. So I don't have to manually take care of cd inside the docs directory, using the make to generate all of the HTML files and validating the build. This particular action called as a Sphinx action basically takes care of that. There are other actions as well, which takes care of different kind of things, and it is upon your requirement to basically find them out. So this workflow would be successful as well because we have not did a lot of things. And this pretty much brings us to the end of this whole talk. So if you have got any questions, you can feel free to put that right now. Otherwise, you can connect with me on GitHub or Twitter, and you can find this talk on this particular repository. I will be keeping it open source in just a few minutes of time.
Thank you so much. And yeah, it's really good. And actually, it kind of remind me of something that I feel that as someone who is starting to just use GitHub Action, a lot of times that they may be actually worry that they may lose their maybe kind of accidentally put their credentials or some secret or API key or something on GitHub Action. So I know that you can kind of put it as a secret, but is there any other tips that you could try to help new users to avoid making that mistake?
Sure. So the very first thing that I had a lot of trouble with was debugging my entire GitHub Action workflow. So when I was working on the SkyPi's GitHub Actions, things used to happen that the action is failing because of some or the other issue. So if you want to debug your your GitHub Actions right on the workflow itself, so we have got some a tool called as a teammate. So I can share my screen and I can directly show that. So teammate is a very popular tool that you can use right here. And what it will do is it will allow you to interact with your GitHub Action host system directly. So you can easily get a URL and you can SSH inside the runner and you can start debugging the whole thing, which is quite revolutionary in the case. Also, if you want to make your GitHub Actions really fast, you can get to use something called as the cache. So GitHub Action has got a cache action as well. And you can simply use it to cache your dependency so that you can speed up the entire workflow. So when I was working on SkyPi, it used to take minutes to basically build and test the whole thing. But right now, if you're using something like compiler caching, or if you're caching your pip or the npm dependencies, the whole workflow is hell faster, and you can simply iterate on it in much better way. So there are a lot of resources on GitHub Actions, and the best part about it is the docs are simply great. So all that you need to do is reach out to the docs if you have any issues, and best of luck creating awesome workflows.
Yeah, that's good. It sounds like a dream come true. It's so easy to use, and I'm sure that is less scary using that. Okay, thank you so much. And so I think that we have to move on now. And Our next speaker will be Miro. And then this is the talk that actually Martin and I are looking forward to. It's called Counting Ships, and there's a ship emoji there. I don't know whether I have the oh yeah, I do have it here. So this is what is coming up now. So with the ship emoji. So without further ado, let me introduce Miro first. Hello.
Good morning.
Good
Is
morning.
it also
I know
morning
it's
for
very
you
early.
now?
Yeah, it's very early. Oh. So yeah, I hope you don't make me fall asleep, because I still have 2 more talks to host and a
I
closing.
was
So
no,
but
it's a morning talk, so I was counting sheep in the evening. Now I have my morning tea, and
yeah, well, I haven't slept, so that would be maybe
how was the
maybe-
conference until now while I was sleeping?
But I will let you just count shifts now. So take us away.
Okay, thank you. Good morning. It's 6:30 here in Central Europe, and this is actually a perfect time for Pyjamas conference because out there it's still dark, and I can be sure that most people in this city out there have their pajamas on and they're actually still sleeping. But I am here. I have my morning tea, and I would like to spend the next few minutes with you. Actually, have you ever observed in the movies when people drink tea or coffee from non-transparent mugs or from cans, that actually there is a whole physics behind holding a cup, because of course you hold and drink from a cup completely differently when the cup is empty and when it is full. And in the movies, when they have to retake the recording several times, and they cannot just drink the whole time, every time full sips of coffee, they have to mask it somehow and try to show that the mug is actually full, although it is empty. Otherwise, imagine them drinking liters of coffee the whole day, and then they cannot sleep at night. And when they cannot sleep, they will actually have to count the sheep and lie in the bed and count the sheep until they fall asleep. We are now in a Python conference. Ooh, let's try to automate this boring stuff. Like in the evening, you have to count sheep. It's boring. Let Python do it for you. So let's ask the first primordial question. Of course, you can count sheep with Python, but the question is, where are you going to start? In Python, we start counting from 0. But is it for humans? Is it natural to count sheep from 0? At the beginning, there is no sheep, 0, and then 1 and 2 and 3 and 4 and so on. So this is something that you have to decide. It depends on your culture. There are cultures that start counting sheep from 0. There are cultures that start counting sheep from 1. Until now, I have never observed a compromise of counting sheep from 0.5. So you have to actually decide between 0 and 1. If you have any other numbers to start from, please let me know. But in Python, you can actually set up such a parameter somewhere in a variable, and then you can start from your preferred number of beginning. The next thing is, well, how are you going to step? So you start with 0 and 1, and then what is the next number? Are you going to count by 1 or maybe by smaller steps, so 0.1, or larger flocks of sheep, like 1, 2, 3, or immediately you are going to count by 10 or dozens? Let's tell us that, for example, in this example, in this tutorial, we are going to count by 1. So we are starting with 0, we are counting by 1. And then the third question is when to stop. So in Python 3, if you use integers, you have no limit. The upper limit is actually your memory. So you can count to any number of sheep. In older Python 2, it would stop at some number, but then you would have to switch to floats that would also stop at some number. But with Python 3, we are on the safe side. And that's actually, we are in the most important point, whether are we going to count in integer or in float. Sheep, like an animal, a piece of animal, is countable. And sheep don't like it when they are cut. I don't mean the wool, I mean like the body of sheep. So usually if you want to count sheep, you have to count them by one. Take one sheep, another sheep, another sheep. In Python, this is also supported by the fact that with integers, you can count safely. You can add one, add another one, add another one. Then if you just made an error, you can count back, like subtract again one number. And then it will always be the same. On the other hand, if you start cutting sheep in pieces, for example, in 1/10 of a sheep, and then 101, 02, 03, and then you come to 1 and 1.1, 1.2, and so on. The problem is that in that case, your sheep will not only suffer, but also your calculation will suffer. Because if you add too many flows after each other, they will not add up to the right number or to an integer again, because that's how the floats work. So please don't cut sheep when you are counting them when falling asleep. So please use integers. In Python 3, you can use integers up to any number. So you will definitely fall asleep, or you will finish and you will always have a nice integer number. So, but how are you going to calculate? So you can have a while loop. At the beginning, I have I equal 1 while loop, and every time I add 1 and print it, or like tell it, or imagine it in my head. But also what you can do is have a range. But the problem with range is that range is defined to finish somewhere. Again, we are in Python 3, so range doesn't create a list. So if you tell yourself, yeah, I'm going to count to 50 trillion, and your memory would explode with all the range of Python 2. In Python 3, you just use a range, and you can have 3 billion or 3 trillion. But then you have to define it. And if you set your number too low, then you will get out or come out of numbers, and you are still not sleeping. So the best way in Python is to use the standard libraries itertools and the method called count, that you will give just the number 0 and then for number in itertools.count, and it will each time it will give you a new number, and it will count until you are done, until you are fall asleep. How to end, how to stop it? So it means that you have to stop it somehow, and maybe you will have to find some way of exception or some detector, some signal that tells your brain you fall asleep, and you want to inform the counter, the code that you have actually stopped, so it doesn't round in the background. So in that case, you will have to program something that's more biology and beyond basic Python. But I would be interested actually in knowing how you do it. Another thing is that your computer or your Python interpreter is fast. So you tell it count, and it does just 0, 1, and even faster. So it will be too fast, and you will get high numbers, and your head will like explode of counting, and would be not able to fall asleep. So you have actually to. In Python, you would have to sleep in between. There is this method time.sleep that you give a number of seconds or a fraction of a second, and you can then slow it down. It is called time sleep. Of course, you are not going to sleep in between. You are going to wait until you can get another number. The problem is that with time sleep, it will be very irregular. Imagine a flock of sheep that is like running there, and you don't have tap, 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 tap. You have something more like tap, 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 tap. So they run quite irregularly. So you could put a random number into sleep, but of course you want to expect that at the end a certain number of sheep would go through, and that's where you can use the random expo variate function that will give you the random number that is that when they are summed up, they will have a certain number of occurrences in a time. So for example, if you tell that you want to have approximately 1 sheep every second, then every second, then you give it the number like random expo variate 1 divided by 1, so it's 1, and this will give you a number around 1, sometimes less, sometimes more. But if you ask it 1,000 times, in the sum it will give 1,000. So the intervals will be right. The number is 1 divided by 1. It means that if you, for example, tell that you want to have 5 sheep in a minute, it means you want to have one sheep approximately every 12 seconds, you have to do a random expo variate 1 divided by 12. And this will give you numbers around 12, sometimes less, sometimes more. And this way you will have a little bit more irregular stream of sheep. But in the sum, the number of sheep within a minute or within an hour will be more or less constant. And that's exactly what you want, because you want to have an estimated or expectable number of sheep that comes in until you fall asleep, depending on your experience of falling asleep the previous days. You could actually apply the whole machine learning on that, but that's also beyond this talk. Pay attention if you start using threads, because then if you don't do it correctly, then the sheep could just come in a different order. And that's exactly a problem. If you have the sheep number 17 comes before the sheep number 16, you will certainly lose track of that, because people are usually trained to remember up to 7 or 8 things at one time, and thread could just throw up the whole the order. And you could forget about which sheep was already there and which is still missing. If you want to experiment with the order, maybe what you think you can do is randomize the order. So there is this random.shuffle function that will take a list, for example, of numbers and shuffle it randomly. This is something that you cannot do at beginning for the whole IT count, because itertools count will give you any number of items. So your list of sheep should be limited, so you can do it by flocks of 100. So you will take the first 100 and then shuffle them, and then you can make sure that actually all of them arrive, and you don't have to keep track of them, because you know that your code is working correctly because you have tested it before. The problem with this shuffling is that although you may think that Python's random number generator can do anything and will give you really truly random numbers, it won't. And if your flock is not so huge, then it will work correctly. But if it is bigger than approximately 2,000 items or sheep, then it is proven that actually not every possible combination could come out, because Python's random number generator is based on a Mersenne twister, and that's a number with about 6,000 digits. And that's actually the biggest number of combinations, or not combinations, but biggest different number of values or a different order that you can get. So actually, you cannot get more than those 10 to the power of 6,000 combinations of or values of random. This means that if you have a flock of 2,000 approximately 2,000 items, and you want to shuffle them, there are actually a little bit more than those 10 to the power of 6,000 combinations, which means that if you have such a huge flock, then with Python you cannot get every possible combination, every possible order. Try it out. You will need several billions of eras of the universum, but it is actually the fact that you won't get all the combinations. Other thing is, so we have the calculation, we know now how to do it, but now you need the output. If you are working with strings, of course, you can use fstring because that's cool, and you can nicely format your output. With fstring, you can also do it more international, because if you get larger numbers, there are some cultures that group the digits in bigger numbers, for example, by 3, what we do it in Europe and in other parts of the world. But in some countries, some languages, they group the digits by 4, and this is something that you can do quite easily with localization. And one important thing is also how you write the word of sheep after that, because of course, you can just output the integers formatted to string 1, 2, 3, and so on. But it's also nice to have it like international and write it, for example, in English, sheep. In English, it's really easy because in English, a sheep is sheep, and in plural, like 2 sheep is also sheep. Sheeps, there is no sheeps. So your code will be really easy. That's based on some old fact that it comes from some old English word that used you as a plural form, and that disappeared during the centuries. And now in English they have one sheep and many sheep as one word. The same is, for example, with deer or with fish. But if you have like plenty of sardines or tuna fish on your table, then you have to tell several fish. Fishes means only more species. With deers, it is also if you have more species, but there are not really more species of sheep, so actually there is no sheep. What you could do if you want to distinguish a little bit in English, you could use the word for ram, like the masculine, and the feminine form is a ewe. It is pronounced ewe, it is written E-W-E. And that they have proper plurals with S, so you have rams and ewes. So maybe you could combine it like that. Or if you write it in French, you write mouton and several mouton. It sounds the same, but in the plural there is an S at the end. Or with German, you have like Schaf and Schafe at the end if it is plural. Much more complicated it will become in Slavic languages, because in Slavic languages they can count up to 5 usually. So for example, let's say in Slovak, you have one is ovca. Ovca, you see that it comes actually from the old Latin ovis, or also in Spanish it's oveja, so in Slovak it's ovca. If you have 2, it's ovce, 3, 4, 5 as well. So they use nominative singular for 1, 2, 3, 4, 5. 2, 3, 4. 2, 3, 4 is nominative plural, so ovce. And as soon as it is 5 or any number, 6, 7, and so on, it is oviec. So it's a genitive of the plural form. It is something based on the size of the hand of all Slavic people. So you will have to actually to count it more complicated in this case. And in other languages, that is really interesting how to count sheep in all other languages, and actually to write the right form of the substantive of the word or the noun of sheep. And now you are already falling asleep, I know, but now you can actually dream about many other possibilities. So you could actually subclass integer. So in IT count, it actually does something very special, and you have certainly many more ideas until you fall asleep. And you see that that's so complicated about counting sheep that's like the physics of drinking coffee from empty mug. And that's all. I wish you good night or good day. I have one slide here. If you want to contact me, I am on Twitter.
Thank you. I think this is like the closest we can have, like for Python Talk to be ASMR, I would say. That's what it is. And I love your slide. Is using human technology to make a slide, which is great. And Martin just joined in. Do you want to say something? Put yourself on stage if you want to.
Hey, good morning.
Good morning.
I was really looking forward to this idea, and sorry, I have to mute the other device. So this was surprisingly interesting. So that was very good. The only thing I think not covered was mistaking sheep for other items. So maybe if you do that again at some point, that could work. Because I think if I'm counting all these things and I'm sleepy, then I might mistake a cloud for a sheep or...
Oh, that's interesting, but actually that's like already image recognition. And
yeah, but I do love the idea of counting float sheep. That is nice. And then you get rounding errors.
Are they like floating sheep, or like float as in like decimal number, like...
So that was a lot of fun. Thanks for doing this.
Thank you.
Yeah.
So thank you very much, and enjoy the last few hours of conference.
Yeah.
Or hopefully to see you soon in person.
We'll let
Yeah,
you get away with,
let's meet in person at some place. Hopefully soon.
We will let you get away with
Okay.
giving a shorter talk. It's fine. So,
Yep.
so we have 9 minutes until our next talk. Because Martin is here, I try to be more precise than I normally would. So
No, totally okay. But well, it's so you had a great night. I peeked in a few times, but not too many. But so I've got some sleep, and you don't, right?
well, I did manage to take a nap, but yeah, like basically, I was here most of the time. But I hope that my tea will give me enough caffeine to push through the rest of it,
Yep.
and then I'll have a sleep like for the rest of my day.
I have the problem
Yeah.
as well. Let's turn
Also,
on the sun.
I'm knitting to try to keep myself awake. So yeah, try not to fall asleep.
Well, this is always the end party of the event, so people can catch this up later. But only the most dedicated people, at least in Europe, would get up.
Yeah, I mean, yeah, it's tricky. It's tricky. But we try to have a very nice talk at the end, so people would be coming back in. So
And of course, it's around the world. So if you're in other time zones, this might be a total normal time.
yeah, I just talk with Jacob because he's in India and talk about maybe all the conferences in the Asia kind of area is like also at the lower like kind of near the time that we are now. So so they have maybe like too much conferences.
Yep. And of course, for this time of year, there's always the advent of code. So people have to get up at 6 o'clock in the morning anyway to solve that riddle.
I can't sleep. I have to count sheep so I can sleep now. Otherwise,
Yeah, I think you don't want to you don't want to program at this time of the day. Maybe sleep and then look at that.
Yeah, and so my teddy bear actually managed to get another debut during when you were sleeping. So yeah, so which is good. But my teddy bear is now sleeping, so I don't want to wake my teddy bear up.
Yeah. And of course, for everybody else who's watching, this guy here is also still here. And this is a live stream exclusive because this will probably not going to be in the recording, at least unless you rewind this one. But this is going to go away. So
you have to find a specific theme, like the frame, the right frame to go to take a
to have like a screenshot of that. But nope. That is a secret for the rest of the world not to see if they don't come and watch the conferences live.
well, we don't have many people right now, so
no, we don't. But hey,
that's why we're so casual right now. Like, even though it's recorded, yay!
Yeah, let's hope that all these stream things turn out. But it's like, oh, there's also a cool bug. Have you seen that when I turn my camera off, that I get Jason's icon for my face?
Oh yeah,
Because
mouse.
I had a little mouse with a bow tie, which I'm normally not supposed to have. So I think if you run the stream long enough, then these things will start to get a little bit unstable.
Yeah, we have.
Unlike the presenters, they're totally fine.
Yeah, we don't have too much issues this year. Like, remember last year we have like a lot of speakers that have. I think because after 2 years of not able to give a talk anywhere else but online, so people are now like have maybe upgrade their setup. I've seen like speaker, they have really cool setup. They look like they're on TV. So I was like so jealous. I was like, I need a good camera and good lighting.
Yeah, well, camera is a thing, and of course people have more practice at these things. And I think the only technical difference we had was a line to Morocco with Yassir. He had to connect a few times, and on Discord he also offered, so if the recording doesn't turn out well, that he's gonna re-record the bits that are missing, because he was cut off I think twice. So I really felt bad for him.
Yeah, we'll try to contact him and see if we can get a better recording to upload afterwards. So yeah, we'll see.
But that's all the problems I know of. There's not much. Oh, yeah, there's also the problems of people not setting up their system at home right, like having background playing videos. But that doesn't count. That's not a real technical problems.
That's not a technical problem.
That's
a common mistake that you and me would make as well sometimes. Yeah.
Okay, and I see that we get the next speaker coming in. So, and I think that's the final speaker that we have today. So
not yet. Too soon. We still have type hinting.
Too soon. Okay, yeah, sure. Then we'll just go and. Oh no, we have type-ins. Yes, you're right. We have 2 more.
Yeah.
Wow.
I'm looking forward to that. Come on.
Come on here. I'm still on that. No, two more, and then of course there's the closing session. So
last chance for lightning talk, please.
Last chance for lightning talks, and then we'll have another year done. It's amazing.
It's amazing. Nothing's better than like a good sleep like after Pyjamas Conf, because I just like sleep through the whole day, which is crazy. I remember last year when I wake up, it's already dark, and then like just go out to get a hot chocolate, and it's the best hot chocolate ever.
Yeah.
All right, so we still have a few minutes, so I think what we would do, like our previous talk, is to play some sponsor video, because there are swags in it, they're freebies, so let people have more chance to scan the QR code and get some goodies, and then we'll have our next speaker on stage.
Yeah, and then we'll have a proper talk. Yeah, I think I'm going to go on Discord as well and scan that little virtual animal thing that you can get from Microsoft, because I don't have a crypto wallet yet, but I think I should scan that so that when I get myself one, I have at least something in the wallet and that it's not empty.
Yeah.
Okay.
So let's do it.
Have a lot of success with the end of the conference, and
I'll see you back then.
Yes. See you later.
Yeah. See ya. I always just abruptly end the music. I don't know how. I didn't time it right. But anyway, let's have our next speaker on stage. Hello. Hello.
Hi, Cheuk.
Hi, Kalyan. Is that correct? Yes. Hello.
Yep.
Welcome to. You are one of our last speakers, like not the last, but also one of the last, which is all the good speakers that we saved till the end.
Yeah.
So we have something good at the end. So so happy to have you here. And then I will also put your screen, your presentation on stage. Then you can take us away.
Sure. So yeah, I'm good to proceed now. All right. Hey, hi, folks. Today I'm going to talk about decision tree visualization, and myself, I'm Kalyan Prasad, and I'm a self-taught data scientist and analytics manager, and I'm a community.
Sorry to interrupt. I think you try to present the whole screen, right? Like I'm looking at your kind of. Right. Okay. We can start again. Don't worry. Okay. Good. I'll let you go.
Okay. Cool. Yeah. So I love being involved with different communities, and I try to help communities as much as I can. And currently, I'm associated with these organizations called PyCon India, PyCon Hyderabad Python User Group, and HFAI, where I have a different roles and responsibilities in each of these organizations. And one of the good thing is I always love to give back to communities. So I always look for opportunities to share my knowledge in multiple ways. Yep, that's pretty much about me. And here is the agenda for today's talk, where we start understanding about decision trees and what type of decision trees we have. And we also try to understand the key elements involved in decision trees. And we'll finally touch up about why D-tree is, and then we'll straight away jump into action to see visualizing decision trees in live, and then I'll conclude my talk accordingly. Okay, all right. So without any further delay, let me get started. So in machine learning era, there are so many fancy algorithms that give more accurate predictions. But when it comes to decision trees, they are very easy to understand because they are pretty straightforward. And also, you don't need much you don't need to have much mathematical knowledge in order to understand the logic behind decision trees. And it is also one of the easiest algorithm in machine learning. So a decision tree uses a tree-like representation or a design and decision model to get actual inferences. So a decision tree is one of the simple and intuitive techniques in machine learning based on the divide and conquer paradigm, meaning that decision trees are constructed via algorithmic approach that identifies a ways to split the data based on different conditions. Now, the idea behind decision tree is to partition the spaces into patches and to fit a model to a patch. In a simple terms, the goal of the decision tree is to create a training model that can be used to predict the value of a target variable by learning simple decision rules inferred from the data aggregate, which is nothing but the training data. Of course, decision trees are also building blocks of many advanced algorithms. For example, random forest, XGBoost, the two most popular algorithms in machine learning for structured data. And finally, decision trees are also a family of supervised learning algorithms. Unlike other supervised learning algorithms, decision trees can be used to solve both classification and regression problems as well. Now, the types of a decision trees are depend upon the type of a target variable we have. So it can be a regression decision trees or it can be a classification decision tree. So how do we identify which type of a target variable when we are working on a data? So the decision trees which has a continuous target variable, then it is called as a continuous or regression trees. For example, predicting a house price, which is a continuous target variable. In that case, we choose a regression decision trees, or that decision trees which has a categorical target variable, then it is called as a categorical or classification decision trees. For example, predicting a risky loan application in the entire loan application. So that's picking a category. So this is exactly how we identify the type of a target variable when we are working on data sets, when we are working on a data, and this is how we identify the target variable working with the decision trees. Now, in order to familiarize with decision tree, we first need to understand the key elements involved in decision trees, or I can also say that is a structure or a flow chart of a decision tree. So it has been primarily classified into three parts. One is like a root node, and next one is a terminal or a leaf node, and finally it's a branches. So we'll understand all these elements by looking at this visual. So the very top of the tree is called a root node, and then we have a splitting. So it is a process of dividing the nodes into two or more subnodes. Then we have a decision node. Thus, when the subnode splits into further subnode is called a decision node. So if you see here, the decision node is splitting into further decision node, which is called as a decision node here. And the node that does not have any split is called as a terminal node or a leaf node. So this is the final node. So you do not have any further splits after when we have a terminal node. And the next we have is the entire subsection of the decision tree is called a branching. So here, this is the subsection of the entire decision tree, which is called a branching. And finally, we have a parent and child node. So a node which is divided into a subnode is called a parent node of a subnode, whereas subnodes are a child of parent node. So in our example, if you see, the A is a parent node and B and C are a child node. So let's try to look some real-time example to understand the decision tree process even much better. So here is a problem statement we have. So a person who has a job offer, whether he wants to accept this job offer or not. So to solve this problem, we'll start with a root node. So the root node here is a salary. So it's a range between the $5,000 to $8,000. And this root node splits into a decision node and one leaf node based on its corresponding label. So the decision node here is a distance, whether the office is near to my place or not. So based on this decision node, so we'll take a decision. So again, this decision node splits into further decision nodes, whether they're providing a transport, whether they're providing a camp facility or not. So, and finally, this decision node splits into a two-leaf node, whether to accept the offer or declining the offer. I mean, like pretty crazy requirements here, right? Because so the person is expecting a good, nice salary, and also quite the distance parameter, and also whether they are providing a transport facility. Definitely pretty crazy parameter requirements. I mean, definitely I'll accept the offer if this is a requirement, and definitely I'll accept this kind of offer. So jokes apart, I mean, coming to our point, so this is exactly how we created decision tree for any data science problem in real time. So I hope you got an idea about how we split the decision tree in a real time. Now, let's jump into our next section, which is called why D-treeways. So before I actually talk about D-treeways, let me tell you some of the issues which are existing in the current visualization packages. Then I'll talk about D-treeways. So as always, it is rightly said that a picture is a worth of 1,000 words. So this principle is almost equally applicable for machine learning models as well, because if one can visualize and interpret the results, it inculcates more confidence in the model's predictions. Makes sense, right? So now visualizing decision trees is a tremendous aid when visualizing how this model works and interpreting these models. Unfortunately, our current visualization packages are not immediately helpful to the noise because we do not have, for example, we do not have any library that visualizes how decision node is split up at a feature space. Of course, scikit-learn inherently has a plotting capabilities for decision trees via a sktree.export graphics function, but potentially it has some issues here. So a couple of problems with the current visualization packages. So do we have any alternative to solve all these problems? So this is where our D-treeways library comes into the picture to solve all these problems. So you'll see all of these issues practically when we move on to our hands-on part. Now here comes our D-treeways. So first things first. So it is a Python library for decision tree visualization and model interpretation. And this library currently supports scikit-learn, XGBoost, Spark, mlib, and lightgbm trees. The best part of a D-treeways library is not only creating a beautiful visual, but also conveying more information about the decision tree process. So trust me on this point. I'll again justify this point when we move on to hands-on part. I'm sure you'll agree with this statement as well. So with the D-treeways library, we can visualize how future space is split up at decision nodes, how training samples get distributed in leaf nodes, and how the tree's prediction for a specific, how the tree uses a prediction for the specific observations, and many more. You'll see all of these things, many more things in your practical hands-on part. So I think so far I've given enough download stuff on theory. So let's straight away jump into action to see some full visualization on decision trees. So let me straight away jump into my code notebook. Okay. So I think so I have already created this notebook, and I think most of the code I've already executed in order to save time. So the objective of this notebook is to show you different ways to visualize the decision trees, and also show you the power of a D-tree-based library for visualizing decision trees. So installed a couple of libraries here called Py.plus, so which shows a Python interface to our graph.image and the graph.is library. So with this library, we can visualize and interpret decision tree results. And with D-trees also, we can visualize the decision tree and interpret the results much better comparatively with the graph.is. So you'll see all this stuff in a while now. So I will install all of them. So as usual, we'll import necessary suspects here. So I've imported a couple of libraries, and what I'm doing is from sklearn, I'm importing dataset. So for this demonstration, I'm taking two datasets from sklearn, one for a classification case, and another for a regression case. So we'll start with the classification, then followed by regression. So for classification, I am taking the wine dataset from sklearn. So I've just loaded the data, and I've initiated my x and y variables here. Now I'm feeding my classifier. So initiated my classifier with the default parameters. So I'm not passing any parameters. So I'm just going with the default stuff here. Now I have fitted my classifier. So from this data set, my goal is to predict the class of a wine, best class of a wine from different classes. So this is our goal from this data set. So before I actually jump into further, so I would like to tell you one important point here is, since the goal of our talk and this notebook is purely on visualizing decision trees. So I'll not talk anything about model building or model accuracy or hyperparameter tuning or any other stuff, etc., because which goes beyond the scope of this talk. So this talk is purely focusing on creating a visualization on decision trees. So I hope you are clear with this point. So we'll start with the traditional ways of visualizing decision trees. So there are multiple ways to do it. So we'll see all of those things in one by one. The first thing is a text representation. So we can build a text report showing the rules of a decision tree. So this is pretty simple and straightforward. So I've created a variable called text representation, where I'm passing a function called tree.export_text, where I'm passing my instance, which is a classification. So it's up to you. You can pass anything, whether it can be a classification or regression. So it's up to you which one you want to pass. So since I'm started with the classification explanation or classification example, so that's the reason I passed classification instance. So once I print this, so there we got a cool textual representation of a decision tree flow. And if you look at this representation, we'll see that we got a futures here, and we can also see the values are rounded up to 2 figures, and we can also see the classification weights, which are the number of samples in each class. Pretty cool, right? And this feature is especially useful when you're working on applications without a user interface, or when you want to log information about the model into a text file. So at that time, this feature definitely helps us. So now another way of visualizing decision tree is with the plot_tree function from scikit-learn. So with this, we can visualize decision trees and interpret our results. So let's see that. So I'm calling my tree.plot_tree function, where I passed my classification instance and also a couple of parameters called feature names. Feature name is nothing but the name of each of the features in our data set. Class name is nothing but the name of each of the target class. It shows in ascending order. And filled equals to true means this method shows the colors. I mean, it highlights the majority of the classes from this visual. And rounded equals to true, which is nothing but I want my figures to be rounded. So once I execute this, so this is how we got a decision tree structure with the plot tree. So this is quite big here. So the reason behind for this big tree representation is we haven't restricted our tree. We haven't restricted our tree size here. I mean, like I didn't pass any parameter to restrict my tree size. So that is the reason we got the entire tree structure on our classification data. So this looks bit cool, but the problem here is it is quite difficult to read this visual, or it is quite difficult to analyze this visual. Even though if I zoom also, for example, let me zoom it also, this is quite challenging to understand the visual or gain insights from this. So how can we scale this image further? So one of the ways, I mean, with the graph is we can scale this image much better comparatively with what we have seen with the above things. So now we'll visualize the same thing with the graphics library. So I've initiated my sting.hivo here and calling my tree.export and graphics function. I'm passing the same parameters what you have seen above. So I want my out file to be in a tree dot. So then once this is done, so this will show you in a graphics.image, and I'm converting that image into a PNG. So once I execute, so after executing this, so this is how we get the image. So this is how we get the decision tree image. So this is very similar with same set of elements with what we have seen above, but the only difference is it shows a very clear and comprehensive picture comparatively with this one. I mean, this is very easy and clear to understand how the decision tree working. But there are a couple of problems here in this visual. So let me address those things. So it is not immediately clear that what these colors actually represents by looking at this visual. And also, so including Gini coefficient, certain cost space here does not help with the interpretation also. So we can see the count of samples in this visual, but it is not easy to visualize the distribution in this case. So this is where our histograms helps in. And if you also observe, the size of each decision node is same regardless the number of samples. For example, if you see the samples here is a 1.1%, and if the samples here is a 3.4%, the both decision nodes look same. I mean, like there is no much difference. There is no difference which is highlighting here. I mean, like couple of problems here, and there are also no names for our target class as well. So couple of problems in this visualization. So this is where our dtreeviz library fits in and to solve all these problems. So this is exactly what I was talking earlier in my slides. I hope you got my point. So let's see how we can address all these points with the dtreeviz library. So far what we have seen are the traditional ways of visualizing decision trees. Now let's see in a dtreeviz style. So when it comes to dtreeviz style, this is also pretty straightforward, and this code is also very simple. So we are just we are just calling our dtreeviz function and passing the same parameters what we have done above. So I'm passing my classification instance x and y, giving my target name, feature names, and passing other parameters called fancy histotype. I want my histogram type to be in a bar stacker, and I'm passing my scale parameter and giving my title. So for the moment, you just remember these two parameters called fancy and scale. I'll talk about these parameters in some time. Just follow for the time being. Just follow me. Just follow with the flow. So once I execute this, there we got a beautiful visual on our wine dataset classification in dtreeviz. Now let's try to understand how this visual conveys the decision tree process in real time. So by looking at this visual, at each node we can see the stacked histogram of the feature that is used for splitting the observations. At each of the histogram, you can see how it is used for splitting the observation colored by class. So by this, we can see that how our classes are segregated at each split. So starting with the root node, you can see how our classes are segregated at each split. And that the black triangle with the value at x-axis shows the exact splitting point. So this is exactly the black triangle, which is the splitting point here. And we can see the class one of a samples that are clustered at the proline feature space as well. And this is amazing. And if we jump to the root node, we can see these are represented as a pie chart, which means that the proportion of what proportion of the observation within each leaf belongs to which class. By this, we can see that majority class and model prediction. So, for example, if you see that, so class 0 is a majority class, and this is our model prediction. So this is how we identify the things with this visual. The only thing which is missing in this visual is about the Gini coefficient for each node. But if you observe that our histograms provide more intuition about the split process here. So I guess the Gini coefficient value is not required in this case. So I think this is a pretty cool visual which you can easily understand. We can easily convey the information to your stakeholders. And if you compare these two visuals, this picture looks more comprehensive and clear, or it conveys a more better decision process information comparatively with this one. So I hope you got a good idea. So by this, we have finished our demonstration on our classification case, and let's jump into our regression case and see how it works. So if you want to use this image, or if you want to use it in your reports, or if you want to use it in feature purpose, you can simply say that save, and it will automatically save this image and you can use it for your future purpose. Now, regression phase. So visualizing regression is not that different. It is almost same like what we have seen in classify. The only thing we need to change here is a target name. So for regression, I'm taking a Boston data set, and I'm initiating my X and Y variables here, and I'm fitting my regressor. And instead of default parameters here, I'm just setting my t size, passing a parameter called max step is equal to 3. And then I'm fitting my regressor. So from this data set, our goal is to predict the median housing prices for certain areas of Boston. So this is exactly what we are predicting from this data set. So we can also do the same traditional ways of visualization, what we have seen in classification for regression as well. But I don't want to repeat and show you the same process again and again explaining. So definitely you can give it a try and explore, but I'm straight away jumping into the D-tree style. So this is again the same thing. So instead of a classification, I'm passing my regression instance here, and rest all the parameters remain the same. So once I execute this, so this is how we got the our visualization on our Boston dataset regression. Let's dig into this visualization to understand how this dataset throws insights from this visual. So in classification, we looked at the histograms of a feature that were used for splitting the observation. But when it comes to regression, we can see the scatter plots of the feature that were used for splitting the observation. And if you also observe this visual, we can see the dashed lines on our scatter plot. So what are those? The horizontal dashed line indicates the target mean from the left to right buckets in the decision nodes, and the vertical line indicates the splitting point in each feature space. And if you also look at the black wedge here, which also highlights the splitting point, and it also shows the exact splitting value here. So if you see this black wedge, which also highlights splitting point, and it also mentions clear the splitting value here. And if you also move to the leaf nodes here, we can also see the dashed line that shows the mean of the target within each leaf, which is also called as a model prediction. So this is how we gain insights from visual, and with this visual, this helps us to build a better models, because we got a very clear picture on how our decision is fitting and how the predictions are coming, and based on this visual, we can build a better models and improve our business much better. So with this, we have also completed the regression case as well. And finally, we have a couple of customization. So the best part of a D-tree library is it offers a bunch of customization. So I have covered a couple of them here on the board data set. So we'll see one by one now. Scaling the image. So as I mentioned earlier, that I'll be talking about the scaling parameter. So this is the time. So the scaling parameter can be used to scale the overall image. So the only thing is you need to pass scale parameter with the value here. So once you execute this, so this entire code remains the same. So I've just loaded my data set and everything remains the same here. So it looks once I execute, so this is how the output looks. It shows a very clear, crisp and short image. So it's up to you that how you want to scale image. So if you want to show it in a very like a very bigger size, you just need to increase the value. Otherwise, this looks a very short and crisp image. So this is how you can scale your image in visualizing with decision trees. And next one is a colors. So colors plays a very key role in the data visualization because they throw a lot of insights from this visual. And when it comes to data trees, so it has an optional parameter where we can pass a dictionary of colors that is to be used in this plot. So this is exactly, so what I'm doing the same thing here. I'm just passing my dictionary colors here, and I want my all scattered dots to be in a green color. So this is how the output looks here. So you can see that how all my scattered dots are highlighting green color, and this is especially useful when you are highlighting a particular point or explaining a particular thing. You can use this color to explain to your stakeholders. See how cool it is, right? And then we have a showed node label. So we can turn on node labels, and this can be done by passing a parameter called showed node labels is equal to true. So this is how you see the node labels on each of our decision nodes. And this feature is especially useful when you are explaining the information to your stakeholders. So you can simply highlight or mention the split point at which you are talking by mentioning the node number. So that is very easy for them to understand. So what exactly you are talking with in your decision process. And next is a simple graph without histogram or a scatter plot for decision nodes. So as the name mentioned that, so do not have any histograms or scatter plot on decision node. This will be a very plain tree plot. So this can be achieved by passing a parameter called fancy. So when you pass a parameter called fancy equals to pass, you do not see any histogram or scatter plot on whatever instance you are plotting the decision tree. So this looks a very plain decision tree, and it also highlights with the colors. But personally, I'm not a huge fan of this visual because I don't like to see the decision tree visual with like this, but because I like to see with the histograms and scatter plots, because that helps me to understand the insights much better comparatively with this one. But again, it's up to nature of interest, so person to person differs. The user requirement. So if they wish to see in this way, it helps them in understanding the decision process much better rather than the histograms and scatter plots. And next we have a tree with left to right alignment. So by default, the tree alignment will be a top to bottom. So, but we can also change the orientation from left to right. So this can be done by passing a parameter called orientation is equal to LR. So so this is how the orientation looks like left to right. So it's again the nature of interest, how you want to see your decision tree structure. If you want to see in a top to bottom, by default it will come. But in case if you want to see from left to right orientation, so this is how it helps. So see, these are crazy customizations. I mean, like which helps a lot of people to understand this much better. And next is a prediction path of a single observation. So this helps to understand which decision path is followed by a specific test observation. So what I'm doing is, in our case, I'm taking a random sample from our data set and transferring its decision path now. So once I execute this, there we got a plot here. So let's try to understand this plot now. So the orange color clearly highlights that which part the observation is followed here. So if you see that orange color has clearly highlighted that which part the observation is followed, and we can also see the orange triangles at each of the histograms here. Each of the histogram which represents the observation value of the future observation value future, and also finally we can also see the feature of the value of the observation, the one that is used for highlighting the decision. So in our case, you can see that there are three features which are highlighting in orange color here. These are the three features which were used for predicting the observation belongs to class 0. So see how amazing it is. So this is how we, this is how we can identify a particular observation and how exactly the prediction process works, and it also highlights with the colors. So which is again the cool thing here in this customization. And next we have is only path. So in the above we have seen that no, we want to highlight a particular observation path. So in this we just want to only see the path, or to say only the nodes that were used for prediction. So again, I'm taking the random sample from my data and transfer it is decision path now. So once I execute this, so these are the decision nodes that is the path that were used for predicting the class 0 here. So this is exactly the ProLine, flavors, and color intensity, and these were the features that were used for predicting the class 0. So see how amazing it is, and how cool these customizations are, right? And next we have is prediction path in plain English. And so this is again a pretty single line of code. So you can simply call explain predict path function, and you can pass a classification instance, X factor, future names, and type should be in a plain English. So once execute this, there we got a features in a plain English. And this feature is especially useful when you are explaining this decision tree process to non-technical folks, because they don't know how exactly it works in technical time. But with this plain English output, or you can simply highlight that these are the features that were used for prediction, so you can easily convey the information to them. And finally, we have is a future importance. So we can model the future importance in decision trees, but in T3 ways, we can also visualize the top features that were involved in the decision tree prediction. This is again a pretty single line of code here, and I'm calling the explain predict path function, passing my instance here, X factor, feature names, and explanation name is a scalar default. And once I executed this, so there you see that these were the top 3 features, which is like RM, CRIM, and LSTT. These were the top 3 features that were involved for predicting the Boston House price prediction. So these are the couple of customization that are involved in decision trees. So to summarize the things, so we have seen that the traditional ways of visualizing decision trees, and we have also seen the issues involved in the current default scikit-learn packages, and how D3VS has solved all those problems. And we also seen how D3VS shows a clear and insightful visualization on decision trees. And we also seen how those visuals convey the decision tree process information to stakeholders, or even for the folks with a less knowledge. So how this visualization helps in real time. And on a final note, I can say that there is so much more you can do and explore with a D3VS library, but I believe this is plenty that you can get started. So with this, I have finished my hands-on part. Let me quickly move back to my slides here. So if you want to explore the D3VS references, so these are the references. You can check out their documentation, GitHub page, and also an article on decision trees in Antixvidya. You can check them out as well. And yeah, with this, I have concluded my talk. And yeah, thank you so much.
Yeah, thank you, Kalyan. It's a very, very good talk, very detailed on decision tree. I think it really helps for all these other, people who have to do some data science work and analytics and stuff. So it's really good. Okay, so thank you so much. And I think we don't have any questions, and also we are kind of a little bit behind. So, but if anybody who want to know more, definitely can contact you on Discord, or via any a detail that you share, they can find you, I'm sure. Thank you.
Yeah, thank you, Cheuk, and thank you for having me today. And it was really an honor to speak to you at Pyjamas, and you've been doing an amazing job. Keep up the good work. Thank you.
Yeah, thank you. So I hope to see you in the future. And yeah, okay. So next we have our speaker, and Anirudh. Do I pronounce your name correctly?
Yes, it's Anirudh.
Anyway, yeah, sorry, it's a bit difficult for me. So you are going to tell us about type hinting today, isn't it? So I'm really looking forward to this because I'm a fan of type hinting. So I will put your presentation on stage and you can start tell us all about it.
Yeah, sure. So, is my screen visible?
Yeah.
Uh,
Okay.
I guess it is. All right. So, hi, good morning, good evening, everyone. I'll be talking about type hints in Python. I'm Anirudh, and I'm from the Python India community. I have been using Python for work and personal use for like I think about a decade now. So it was a nice talk from Kalyan earlier. So I work with Kalyan too on, and I'm part of the Python group in India, like I said. So let me get right into it. So first off, I'm going to start with what is type checking, and then move on to what type hints are and how it's used in Python. So type checking is the process of verifying type safety in a program. So generally, when you talk about programs which are written in C or Java, it's generally this is the part which generally happens during the compile time. So here, in case of Python, since we don't have really a compile time and then a runtime, what happens is you need to use a separate type checker in order to check types. So there is some runtime type checking, but then that's usually too late to check types, at runtime. So that's primarily the focus of the talk. I'll be talking a lot more on type checkers and how a type checker can be used and what are the different types of type checking that we do. So type checker is a tool which generally looks for types and number of arguments and everything around the different types so that the type safety is maintained within the program. So type checking may happen at compiler runtime, as I said. And here is an example which you can see. So here, if you see what I've written, the example is a single line code where I do 1 plus a string 2 if false and else 1 plus 2. So what is happening here is the first piece of code is never going to get executed because that is in if false, and it's only the else part which is going to get executed, and you can see the result 3 is printing out. So one of the things to look at here or to point out here is that any code that is not run is not really type checked in Python. So when I directly run 1 plus the string of 2, it throws me an error. It says that it's an unexpected operand. It's expecting an int there. That's an example of why type check is required also. And coming to type hints. So type hints was formalized and brought up in PEP 484. And it also kind of introduces gradual typing in Python. Python is actually a nominally typed language, and you can say it's people say dynamically typed or duck typed. You could use any of these. So now with PEP 484, it's kind of a gradually typed language because for people who are interested to statically give data types, they are allowed to, and standard syntax with type annotations has been defined for this. So that's what 484 brings onto the table, and Python makes it much easier to add static analysis of types now. So here's an example. So in the generally when you write type any kind of code in Python, it's usual to have doc strings which are of this type. So here you can see there is a function called hello. It takes an argument name, and it has a default parameter nobody. Right? And the doc string says say hello to a person. And here you can see there are two statements in the doc string. One called param, which says string value is what is expected, and another called return, which says string value is what will be returned. And the return, that's the body of the function, says hello followed by the name. So how you would write this using type hints is what you can see on the right. That is, you say hello, the name is of type string, and the default is nobody, and the return type is string. So you can see it's the exact same function, the same functionality, but it makes it much easier to read and also much easier to type in as well, right? You don't have to write as many words. So that is what type hints again gets to the table. So typehints is bought in Python as part of the Python typing module, which is present by default in Python from Python 3.5 and above. So going a little more into typehints on why and what they do and what they don't. So why type-ins? So type-ins catches most of the bugs as early as possible. So generally what happens is you write a lot of Python code, you write like 200 lines of code and then put it in production, and then that is when you realize that, oh, there is a type mismatch somewhere, right? So it catches certain types of bugs, specifically bugs which relate to types much earlier than pushing the code into production. It also helps in refactoring and updating code much more confidently, because you would know what are the expected types, and you can also define what are the expected types and easily check it before the code is pushed into production. It improves readability, like I just showed you in the last slide, that code is more sufficient and more precise on what exactly each type it is expecting for an argument or for a variable, and what is going to return, right? It's also easier to tie into any kind of continuous integration. So if you use a type checker like MyPy or Pyray or any of the type checker, it's very easy to integrate it into a continuous integration tool, so that during the pipeline it will automatically do type checking for you, and then there is no performance impact on production as such. And if you use an IDE, of course, if the IDE supports something like code generation based on type information, that is again one of the reason for you to use type info, because it'll be able to give you, all kinds of suggestions based on the types that you use, and that is why you need to use type. So what it is not, it does not fix all issues that come up. It fixes very specific issues, like I said, and there is no performance overhead as such on at runtime, because type checkers run before runtime. You generally run something like a MyPy during your continuous integration, and that specifically pulls out and tells you which are the errors, which are the lines where certain kind of errors are coming up, and specifically related to types. And again, it doesn't make Python a statically typed language. So like I said, Python is a nominally typed or gradually typed language. Now, after the typing module has been introduced, it's a gradually typed language wherein you can add statically typed annotations as required. So you can see the meme on the right. You come to me at runtime, then you tell me the code you're executing does not compile. Well, you don't want that to happen. That's the reason there is an option for you to structurally subtype and statically, you give annotations for static typing. So how do we do it in Python? So how do you do it in Python is using type hints, like I said earlier. So let me just walk you through how it used to be earlier. That most people used to give static types this way. That is, you define a function, for example, add, which takes two variables, a and b, and then returns a plus b as the return. So what you do is you give a comment saying type, and then you say float and float are the two arguments which you're passing in, and float is a response type. So this is the old way of doing it in Python 2. So again, this is just a comment actually, and it's not. Most of the type checkers don't even pick this up. And so in Python 3 is where we have this type annotation, like you can see here, where you can specifically say A is going to be a float, B is going to be a float, and the return type is going to be a float. So this, as you can see, is much more sufficient, easy to read, and much more easier to type in as well. And the type checkers generally pick it up directly. So how it is supported is through the typing module, as I was saying. So for all versions, Python 3.5 and above, you can just import typing to add these annotations. And for versions 3.2 to 3.4, you will need to do a pip install of it. And MyPy is the type checker that I'll be using, and I'll be kind of talking about in a while. So again, it's just another type checker. There are multiple options that you have. You have Pyray, you have PyType, and many others. Talking about annotations, so I kind of showed you an example of how function annotations work. All the argument annotations and return type annotations inside a function work. Now, there are also variable annotations. When you define a variable, you can say what type of variable it's going to be. So x int equal to, and then you can give the value. The three dots that you see are ellipses. So these are generally used in stub files. So stub files are like files used for type annotation specifically. But you could use them in your Python code as well. You can just say x of int, and then you can give the value, for example, 10 here directly. Now, other than this, there are special forms. So this is something that is very interesting. So special forms are special type of annotations which are defined using square brackets. And so here are some of them that I've named. So tuple type. So what tuple type means is that it's a variable of type tuple. So in this example, I've taken tuple of x comma y, which means there are two values in the tuple. The first value is of type x, and the second value is of type y. So it's a tuple x comma. Then you have union type. Union type means that the value is either going to be of value x or y. So in this example, I'm taking union of x comma y. So the argument is going to be either an x or a y. Then you have optional type. So I'll be going into some of the examples after this. But what optional type is, what it means is that the argument may or may not exist. So if it exists, it is going to be of type x, or if it doesn't, then it's none. Then you have callable types. So callable types are more like when you're making a call, the function is going to be of the callable requires an int to be passed, and it is going to give you back a string. So that's the example I picked up: callable int string. And there are many others like literal, final, annotate, and all of these which have come up in Python 3.9 and 10. I don't want to go into all of them, but you could go and explore them. So then you have functions and decorators. These are again a very important part. I will be going over some of them in the examples which are going to come up, but at a high level, cast is a function which can be used to cast into a particular type. Overload is a function which can be used to, it's a decorator which can be used to decorate multiple types of a single function, or overloads of a different of a single function and all that. So I'll be going to examples on those. So then you can use no type check and type check only decorators as you require to in order to skip type checking some of the functions and all that. And then there is final, which means that a function cannot be overloaded, basically. And then there's a constant called type checking. So this constant is quite interesting because you could just define this constant, and what it's going to do is you can give basically a condition that if type checking, if this constant, then do something, right? So if type checking is enabled, then you can do probably something like reveal type. So there's something called a reveal type inside MyPy, which can be used to reveal the type of particular variable that you're using all throughout. Right? So variable as an object, because in Python everything is an object, and a variable is just really a object with a binding name on top of it. So yeah, you can really do a type check of any object that's there using reveal type. Right. So yeah. So this is a tweet which came out, I think, a few months back, when David said, uh, if this is how Titans are gonna be, I wish I had a desk side bridge to jump off, because that's how bad it looks, right? So you can clearly see, there's a function called read CSV, and we actually just have a few arguments which are passed, lines, types, headers, and then you can see the typings which are used, like iterable of string, a sequence of a callable of a string or any, and then a sequence of a string. That looks really confusing. And then the return type is a list of addictive strings. Right? That's quite confusing. So that's the reason. One thing is being made clear in PEP 484, that Python will remain a dynamically typed language. So all this jazz is not really required for everybody. But if you really feel, or if you think you can utilize static type analysis at some point, which is really good from an engineering standpoint, then you can go ahead and use it. So Python is still going to be very much a duck type language. For folks who want to use static typing, it is, functionality is there. That's about it. Now going over to some examples. The first one I'm going to talk about is optional. So optional, as I pointed to earlier, is a way to define if a particular argument is going to be optional. So here I've defined a function add, which is very similar to what we saw some time earlier. Earlier, I just had two arguments. Now I have a third argument, which is optional. So now I have A is float, B is float, and C is optional, which may be float, or the argument itself may not exist. And also there is, I mean, the argument would exist, but with none, right? So now if C is passed, then you have to use A plus B plus C, otherwise you have to use A plus B. And the return type is always going to be float. So this is where optional can be used, because if you do not specify this, if you just give, C equal to none, what's going to happen is that the second return is going to throw you an error, because there is no C that's used, and then it's going to throw you an error because you're actually trying to define kind of an overload. So there is another way to do this, and I have kind of spoken about that in the next slide. So one of the things that you can see here is be liberal in what you accept. Be liberal in what you accept, as in you can accept as many arguments and different types of arguments and all that, but be conservative in what you return. So you can see the return type is clearly float here. I'm not giving multiple options for that. Now going on to union and overload. So here I'm talking about union type and overload decorator. So first let's go into just the definition of the function. The definition of the function is line 9 and 10. So it's the same add function which I used, like I showed you in the previous slide. We have A, B, C in 3 arguments passed. And what I'm doing here is A can either be an int or a float, B can either be an int or a float, and C can either be an int or a float. And based on those inputs, the output can either be an int or a float. Now the problem here is if you just define it in this way, just the line 9 and 10, what's going to happen is MyPy is going to get confused, because no matter you give an int or a float, your result can either be an int or a float, right? So even when you give 3 ints, your output could be an int or a float. So now that's confusing. So that's why we require something like this. There is something called overload, which is a decorator which is defined in typing, and you can use the decorator this way. And it says for add, when A, B, and C are ints, the return should be an int. And when A, B, and C are floats, the return should be a float. And here you can see the ellipses are used. Ellipsis means that there is no real implementation here, but this is just primarily for MyPy or the type checker to use. And the definition is what you see below. So you can have all of this overload and all of this type checking in a different file, a stub file. But yeah, I've just put it all here together. There will be no errors if you execute this. This will work perfectly fine, and the output of this would be 10 plus 20 plus 30, 60. That will be the output. Yeah. So thank you. So that was my session. I hope I didn't take too long, and I've covered most of what I wanted to. So that's about it from me. There are a few references which I used. I've used the typing module, the docs of the typing module. I've gone through PEP 484 and PEP 544, and also some other PEPs, and also went through a Python page and dynamic languages. And I mean, why we kind of need a strongly typed language, why we want to kind of have the option for Python to have the strongly typed syntaxes and all of that. And then some of the decks from Luciano Ramalho and Guido were very useful as well. And of course, the David's tweet, which I shared earlier. Right? So these were some of the references, and otherwise I've been using typing for a while now, and it's quite powerful. And the type checker I use is MyPy. But there are other type checkers. There are a few of them like PyWrite, which is by Microsoft. There is PyRay by Facebook, and PyType by Google. So Python interpreter does not automatically conduct any kind of type checking whatsoever. So that is one of the things. So what people would do if there was no type checker is that they would use something like a is instance. So within the method, you will have to do something like is instance of int, is instance of float, and then you will have to write a whole lot of if else's to handle that. So currently that's one of the things which we can overcome by using type check. Yeah, so that was it from me. Any questions? Feel free.
Yeah, thank you so much. Do we have questions? And I think that right now we don't have any questions. So if anybody who have questions, definitely they can find you in either Discord or somewhere else, and I'm sure. But it's really good. It's very detailed, and yeah, I use type hinting a lot as well. There's a lot of little things that I saw hidden. I think people didn't pay attention, and it's really good to have such information that is provided. Okay, so I think that our last session is ready, so I'll let you go and hope to see you soon.
Yeah.
Okay, so yeah, now we exciting lightning talk time now. But before that, for the last time, we gotta let our sponsor to give you the last chance to snap the QR code, which is your chance to get some freebies. It's really good. So let's enjoy. Okay, so it's our last session, and it's time to say goodbye. But before that, we have lightning talk, the most exciting part of the conference usually. But unfortunately, this year I think because it's the first time we do lightning talk, and also we kind of secretly slide it in, so I think people are not expecting that. But we do have one very willing speaker that's coming on stage. So we have Jacob here. Hello.
Hi, welcome back.
Yes. So yeah, because you are the only brave soul that joined us for lightning talk, I'll give you more than 5 minutes. But please don't get too long because my
No,
teddy
no,
bear
no,
will
I
go to
won't.
bed.
I prepared myself for this. Like I was like, I was really excited because lightning means it'll be fast and everyone will listen because it'll be just short enough for people to listen to right before bed. Maybe
Right.
not boring enough. So
Okay.
my project is, well, my talk is actually about something I do at work. So I think we can start like this. Imagine a world where every project you're building is used by only a handful of users. These users are understanding, they're feedback driven, and malleable to any changes or downtime. Well, now open your eyes because such a user base does not exist. Building for scale is actually a common occurrence in the developer world, and it is absolutely necessary or quintessential for every developer to know how to do so. Every major company requires minimal downtime and the quickest possible experience for a customer. However, building at scale can be a massive pain in the backside. It takes a tremendous amount of organization, skill, and patience. In fact, even after meticulous planning, it isn't guaranteed that your application or your software will be able to cope up with the dangers of the load it needs to handle. And this is particularly exacerbated in a densely populated country like India. Now, from a business point of view, this is an absolute nightmare. Like, imagine investing a sprint or two worth of effort only to see your application plummet into oblivion. Developers are expensive, and so is software. And every week's worth of effort is a buttload of money down the drain, all because users didn't like your product or it just didn't fit the market, right? I mean, it sounds like a really, really horrible scenario ultimately. But what if I told you it doesn't always have to be this way? What if I told you you can ship a product out in a week and get a reasonable amount of sleep? Are you getting the chills? Because the first time I heard about this, so did I. Because the principle we operate on in Grofers or at the Innovation Hub, a place where I work at, is called the sprint or a week sprint. So Grofers, a little bit of a background here. Grofers is an e-commerce platform that operates out of India, and we have a tremendously large user base. In fact, I think just in a day we get 300 million users, which is almost close to the population of the United States entirely. And we specialize in deploying things quickly and effectively. And by effectively, I don't mean using the highest quality loggers and debuggers. By effectively, I mean you build a product for long enough just to collect enough data to know whether your product will fail or succeed. And my mindset or our mindset follows along the lines of, you don't need to build anything and everything. You just need to build just enough to give it a try. Anything and everything we build in our team starts with a metric, all right? It could be cart value because we are an e-commerce platform, user retention, number of checkouts, and so on. So you start with the project and you'll say, okay, my aim is to make sure that the metric I optimize for is one of these, and that's it. That's all my product is going to do. In fact, let me highlight this with a real-world example. I'll step back a bit and give an example that is well understood by all. Let's say you're working in Netflix or a movie platform, IMDb, for example, and you want to build a system that notifies a user every time a movie of a particular genre releases on your platform. From a business point of view, it makes absolute sense. It's incredible. It's excellent for retaining users. Everything here goes hand in hand. You buy a license for a movie as a company, not as a user, and the moment it launches, the users storm in and watch it because the user has subscribed to this movie or this genre, and they know that they will want to watch it or hopefully they'll want to watch it. So ultimately, what's going to happen? the more movies you buy of this genre or the genre people have subscribed to, the more your user base will return. Simple, right? Not actually from a software point of view. It introduces a tremendous number of complications. Like for starters, what platform will you run this on? What software will you use? How will you send notifications to a variety of devices like Android, iOS, the web? How will you ensure that the deep link or the link or whenever the user clicks on the device, they will be able to get into the movie directly and it will play? Do you keep listening for the event? Like you keep listening for the event on your platform saying that, okay, my API or my software will say, okay, well, look, a movie is releasing. Is the movie releasing now? What time it is going to release? Or do you build a producer-consumer model? It's incredible how many complications it can bring about. And most software developers here will agree with me. It's not easy and it'll take a lot of time. Well, at the Innovation Hub, we'll say, okay, scrap all of that. Let's ignore these complications and answer this question. Is there a way I can build something simple enough such that I can verify just retention? Is there something I can use within my company which I can leverage rather than building something entirely from scratch? Then ask yourself maybe this thing. What if I can do this for 10 new movies rather than every single one? What if I can just manually push out a notification every time one of these movies launches on my platform? Do I have to really do this for everyone? Or can I just use this for a small consumer base? Because ultimately, you're just trying to test things out. You really don't want to you don't want to ship out a complete working project just yet, because that's expensive, remember? Now, if you were to do this on our platform, which is Grofers, we could easily, what I would do is I would just add a notify me button on my movie page. And every time the movie releases, every time the user clicks on the notify me button, it will send a webhook to one of our existing in-house built APIs. So the API will log that data, put it in a database, and I can query it anytime I want. So as a business platform, I know when and what time the movie will release, because I'm the one who bought the license. I'm the one who has planned the movie releases. So all I'm going to do is I'm going to read from this database, leverage the notifications engine, which is also available at Grofers, and it's built in-house, and send a notification to one of these users who has clicked on the notify me button, because I have this list of users. I don't need to do anything severely complicated. I just need to connect these systems together. In fact, I don't even have to do that. It's 10 movies. I can just do it manually. I can get a guy, or I can do it myself, rather than spending hours and hours of effort planning out a system. Okay, now, finally, rather than deploying this for 100% of our user base, millions of users, I could start, with one of the popular cities like Delhi or Mumbai, which are incredibly well populated, but I don't have to roll out to every single user in Delhi or Mumbai. I could just maybe use 10% or 20% of the user base. Okay, but keep in mind, see, as a data scientist, I would say maybe that might not be a good idea, because from a statistics point of view, it could introduce some biases. So because you're choosing a user base that is more likely, because it's a metropolitan city, it's more likely that the user base there is going to be active. Therefore, the insights you derive will be biased towards the active users rather than all the users. But what you can do is you can identify these biases, and during a shareholder meeting or a business meeting, you can say, okay, these are the biases in my project. So everything I'm telling you here, take it with a grain of salt. In fact, from a business point of view, although, ignoring statistics for a second, a bit dangerous here, you could say that, okay, well, if it didn't work for Delhi or Mumbai, will the system really work for everywhere else where the footfall isn't necessarily high? And that's it. That's all you have to do. Utilize whatever is there rather than building something entirely from scratch, and build a system just simple enough for people to try out. If there's anything you take away from these last 5 minutes, it should be build quick enough to get feedback, because ultimately, as a software developer, you're not creating software for the sake of creating software. You're doing so to solve a problem for someone else. All right. And all credits go to the book called The Sprint by Jake Knapp. These ideas of a 1 week sprint aren't necessarily ours or mine. We've just taken it and tried to make it our own. And I highly recommend for those who want to try this methodology out to read the book. It's probably 2 or 3 hours worth of a read, but it's an excellent book. And I recommend everyone to experiment things like these in their team. That's it. I think you guys can come up again.
Good stuff. You didn't overrun in 10 minutes. Yeah. On point, sharp, perfect. So yeah, like I think I would just jump right into closing now. So my closing would actually be just like another lightning talk. So I would let you rest a bit, Jacob. Right. At the end, maybe we would just have everybody on the stage. I don't know. We'll see. We just now it's not organized. Everything is not organized right now. So I will just share my screen here right now. Oh my God, I'm just like, right, cool. So hello there. I can put myself in the corner. I think still playing around with this kind of setting. Maybe you don't have to look at me because I think you're sick of looking at me already for the whole day. So yeah, thank you so much for joining Pyjamas. And well, this year we have like last year we have like non-stop streaming. We have keynote and panel session. We have 39 talks because I think that I should not count the keynote, but also we have also talk that we play twice. So I don't know. It's not very accurate counting. So don't blame me if the number doesn't add up. I can't do math right now. I'm too tired. So yeah, if you want to check our schedule, is there check like maybe you missed a talk, you want to catch up. Right now, all the live streams should be available, so you can kind of look at what time it is and try to like look for the right stream and then try to find it. But after that, the team will be trying very hard to you know, tidy up the video and have, you know, just like last year, we have all the videos that is like kind of published. But that takes a lot of effort. And if someone very kind to be able to mark all the markings. So last year, actually, Jasper helped us to do that. So if any of you want to volunteer, you're very welcome to put all the timestamp as a comment in the stream so we can easily find it. That would be great. Or if you don't want to comment, you can just like email us the timestamp. That would be a great help. So Discord channel. So this link will still be available, I think, for one more day, but it will be because like, I don't want to have a permanent link that anybody can come in. So I just want to be people who are really interested in the conference to come in. So it won't be available forever. So if you are watching these further in the future, so maybe the link won't work anymore. But yeah, just follow us on Twitter. If we have another conference next year, then you'll be the first to know. Also know what we're doing with the organizing thing. So also we have no code of conduct issue reported. Well done, everybody, being a nice human to everyone. So that's really good. We have a few tech issues, which is not a big deal. We have you know, only I think one speaker having some technical issues that we may have to contact them to see if they can record it afterwards to have a better video, but we don't know yet. So, but we will try to make sure that you know, you have the best viewing experience afterwards. We had ice cream. I had ice cream. I hope you also have ice cream. We have lots of fun, lots of laughing, lots of you know, very. You know, some talks are very, you know, informative. Some talks are very funny. You know, we have a variety of talks. We have a lot of fun. So there's the link. There is the last chance you can get your ebook. I also put that in the chat. So yeah, like your last chance. So please, you know, it's free. You know, just don't miss your chance. Especially if you want to learn Python. I think now you have free resources that you can learn Python. So why not? Yeah, and again, thank you so much for our sponsor. We have our Silk sponsor. I can't speak English. Microsoft. Thank you so much. So you can still jump into our Discord channel, and they have a lot of freebies there that you could scan the QR code and you can have some really fun e-swags. And also Pact is the sponsor for all the ebooks, lucky draw that I've just showed you the link. So make sure that, you know, don't miss the chance. Just, you know, try to get a book. Why not? Also, thank you to all the speakers. So all of their information will still be on the website for a little bit longer. So again, if you have a specific topic that you're interested in, feel free to go there and check if there's a talk that you have missed. You can also like go back to YouTube to watch the recording. So and the picture is not loading. I'm so sad. You know what? I'll just put two of you on stage right now. I don't know why the picture is not loading. So,
Oh well, that's because you were supposed to say the thanks in person. So, what pictures do we have there?
Well, I just screen cap all of your pictures like right on the stream. So,
well, we're on live.
Fast looking one for all of you. But Jason.
Yeah, and of course, we also have to thank all these that you can't see at this moment because they might be asleep in the US, for example,
yes.
And some of the other people who have looked at all the reviews and everybody who has sent in talk proposals. So without all these nice people that want to take part in this and want to help with this would have not been possible to do again. And so thanks to everybody who helped out. And yeah, that's about it, right?
Yeah, so thank you so much for anybody who volunteered themselves to help out. So this year, actually, we have a very tight schedule because of COVID and also a lot of stuff. So everybody who offer help is actually a great help. So thank you so much for anybody. Even like the speakers, they are like very happy to just use the template and promote the talk themselves, like rather than waiting for me to do because I can't do all of these kind of pictures for everybody and promote them. So yeah, so that's thank you so much. And the last thing I want to thank is my better half. Just sneak back in. So thank you for feeding me and taking care of me while I'm busy at the conference and also not being able to sleep. So yeah, next year shall we have another conference, another Pyjamas 2022? Yes,
definitely,
no?
Absolutely.
Yeah, of course,
100%.
that is so necessary to do this again. And in December, it's the perfect time to do this at home. So. Yeah. I think we should do this again next year. It's gonna be Pyjamas 4. That is.
Yeah, well, just for the year there, so there's no ambiguity.
Yeah, and I really hope that we will all get through this next year, and that things will work out, and that once this winter is through, that meeting is somehow possible again. Like for the summer conferences, like Berlin, for example, is currently still considering to host. So let's see how that plays out. But EuroPython is in summer, so and let's really see that we'll do some. If not, we'll just do a live Pyjamas, and then you all have to come. That would be fun.
Wow, we have to meet in person in Pyjamas. I don't know. Let me think about that, but definitely, if any of you actually not just any like people who have helped out this year, like any of you who have been listening in and really like want to help organizing or just like or maybe just I want to try being a host or something like that, just what you have to do is very simple. Just follow us on Twitter when we have news. So hopefully like when we have any news, we just like put it on Twitter and tell everybody. YouTube, you can look at us up by typing Pyjamas Conf. I think it's difficult to find us by just typing Pyjamas, so type Pyjamas Conf. So you will find us and follow us. Make sure you follow us. And also emails, or if you have some specific thing that you want to ask, or so like Jacob just like email us before and to volunteer himself. So if you do it very early, so sometimes the email may fell through the inbox because I'm not checking it very frequently unless it's very close to the conference. I'm not very organized. Sorry about that. But you can still email us. If I see it, it may be slower if it's not like the time that I'm checking the mailbox so frequently. But let us know if you really want to help. So I think that's the end of this session and also the end of Pyjamas Conf 2021. So see you next year. And I have to sleep, and my teddy bear needs to sleep. All right. Okay.
Okay, yeah. Then also, like, goodbye from me. See you all next year.
Yeah.
See you guys.
See you.
Bye.
So shall we play the music for one last time, or just?
Yeah, we should have done a we are not coming back for the end of the year thing. But we should play we should play you out with the music once more, and then hope to see you again next year.
Well, it's not coming up next, but we would just play the music for one.
Well, you could just coming up next, Pyjamas 2022.
Oh yeah, we can do that. Let's do that. Like just
Because it is going to happen.
Well, like who knows? It's supposed to be I am too. Yeah, okay. Someone did it. Thanks.
Next.
I'm too sleepy.
2022.
Yeah, that's and we could maybe decide. No, we don't. The date will be on Twitter, so it's probably gonna be around this time.
Yeah. Just okay. So yeah. So someone please. I'm hand off the wheel.
Yeah. Okay. So
press the explode button.
So I'm gonna press the button. So thanks, Cheuk, because you did the major part of this work, and we'll all see you again next year. Bye.